Okay. Good afternoon and welcome to all the participants of TICCAS 2025. Today we are in the final day of our DP on technological innovations in climate change adaptation for sustainability. And today the first session will be addressed by Dr. Ajit from Delft University of Technology, Netherlands. Now I am introducing Dr. Ajit. Dr. Ajit is currently working as an assistant professor in the Faculty of Civil Engineering at Delft University of Technology, Netherlands. He completed his PhD from CSIR, National Physical Laboratory, India, in the field of aerosol instrumentation. Dr. Ajit then worked as a scientist at Leibniz Institute of Tropospheric Research, Germany, for almost 6 years, contributing to the advancement of air pollution monitoring through ground-based and airborne field campaigns. He has coordinated various projects on air pollution monitoring in India. He has published around 30 research papers in various reputed international journals. Now I am cordially inviting Dr. Ajit to address the session on behalf of our participants. Hello, Dr. Ajit.
Hi. Hi,
Welcome,
Dr.
sir.
Raut. Hi. Thank you for the nice introduction and thank you for inviting me to present this the work on this really important topic that stands from its name, technological innovations in climate change adaptation and sustainability. And I would also like to thank all the participants for coming on Saturday. And good morning from this side in the Netherlands and good afternoon in India. And I would like to share my screen to start with. I share the screen is from here. Where is the screen sharing option? So there's some options coming to allow, and I think now, do you see it? This, the
Not yet.
presentation? Okay.
Yeah,
So
yeah,
I'll
yeah, yeah.
put it in this mode and let's start with the presentation. So as it's already being introduced that I worked as an assistant professor in Delft University of Technology in the Netherlands. And today I'm going to start my topic that is flying into the future by harnessing drone technology for air pollution monitoring and climate change adaptation, which quietly match with the title of this conference. So let's delve into the content. So today I'm going to present the overview of air pollution and climate change, why it is necessary, like why should we bother about monitoring air pollution and why should we care about climate change, a bit of both of those topics. Then what are those traditional approaches for air pollution monitoring, and what are the challenges that traditional air pollution monitoring faces. So that's why we shift to the newer technology. So what are the roles of these new technologies, especially drones in air pollution monitoring? How come drone could be really handy or useful in climate change adaptation or climate change research? What are the challenges that these technologies face in current scenarios, and what are the opportunities lie ahead in future? What are those future trends and innovations in drone technologies or instrumentation? How it will be helpful in air pollution monitoring in the future? What are the conclusions or key takeaways? And finally, we're gonna address some of the question answers or discussions or a kind of interactive session for a few minutes. So let's start with some of the content that is mainly the overview of air pollution and climate change. So as most of you are aware about these kind of pollutants that cause climate change or that has impact on air pollution. So basically this figure represents you mostly the climate change, air pollution and health nexus, that how these primary and secondary pollutants that are being released from variety of different sources, from urban to rural scenarios, from natural to anthropogenic emissions, and how they impact human health, how they change our scenarios of our cities, air pollution, and how they exacerbate this climate change situation. So if we go deeply in this figure, you see that there are two different sources that they are divided into, that are mainly primary pollutants and secondary pollutants. So the primary pollutants which are being released from variety of different sources, and secondary which are formed due to some chemical reactions interacting with solar light or interacting with radicals that are present in the atmosphere. And if you see in the left panel, it starts with all those big sectors such as energy sector, industrial sector, or transport sector. So they release particulate matter, black carbon, volatile organic compounds, gases such as carbon monoxide, nitrogen dioxide, sulfur dioxide, and some of the other gases such as carbon dioxide, nitrous oxide, something like that. And then you have contributing factors from agriculture, from the pest spraying, or from coming from the livestock farms, right? So they release this ammonia or methane. So these are primary contributors of these gases. And then you have other sources like cooking, heating, waste burning. So these sources also release particulate matter, volatile organic compounds, which later interact with some gases and form ozone, that is a secondary source of pollution. Then you have wildfires or natural sources that are occurring in our atmosphere, on our surroundings, that also release quite a lot of particulate matter, black carbon, primary pollutants that are referred to. So these, you could see from the air pollution point of view, that we have marked these as like PM, BC, or carbon monoxide, or variety of gases. But then specifically those greenhouse gases that are contributing to climate change, that are mainly highlighted in orange color, that is nitrous oxide, carbon dioxide, methane, and then ozone. Or you could also see that OH radical or water vapor could also be a major source of the greenhouse impact that has on climate change research. Then we would like to see the cumulative health impact. So I will go to deep in the next slides, but here just we refer that what are those, like these can impact our cardiovascular system, respiratory system, then have impact on low birth weight, preterm birth, children and elderly at increased risk because of these conditions. Then let's move to the sources of air pollution in a bit more different way we visualize. So basically here we are talking about mainly those cities which are on ports such as Singapore, or cities here in the Netherlands like Rotterdam. So we have impact from vehicular emissions, especially those heavy duty trucks, diesel trucks, or industry, or then we have from this ship-borne air pollutions because of this port. There are a lot of activities of these ships, good carriers, and both of they release quite a lot of PM, as we already mentioned in the previous slide, and BC and carbon dioxide, carbon monoxide, and then later we get as a secondary ozone, and how they interact with our system, climate change, and lung, actually the health, because they impact our lung and other diseases. So this is, we are talking only about the sense in the respiratory system wide, but as I already mentioned in the previous slide, that there are all other body parts that are being affected from these air pollution sources. So we will see more of these sources and health impact in the next slides. But before going further, let's see the major formation mechanisms of this air pollution from two basic scenarios. So we are talking about these contributing factor as aerosols. So these primary pollutants which are released, like we talk about this PM, particulate matter. So we term these as aerosols, or tiny liquid or solid particles suspend in air. So let's see now from this figure. So as I already mentioned in previous slides, that variety of different sources contribute to primary emissions. So there are industrial, from transport, waste burning, thermal power plants. So these primary emissions release quite a lot of gases such as nitrous oxide, sulfur dioxide, and volatile organic compounds. There are a lot more volatile organic compounds. So we just categorize them into one. And then we see when they interact with OH radicals, which are mainly present during a day, that is during sunny day. So they, or they are present actually, but most of this interaction happens during daytime. And then we have another factor, that is nitrate radical, that most of the times present in air in the nighttime, and we have nighttime chemistry. So there are photochemistry basically due to OH radicals, and then there are nighttime chemistry basically due to nitrate radicals. So then these volatile organic compounds, they get oxidized. They get oxidized when they interact with these radicals and form oxidized volatile organic compounds. And then they subsequent grow, and then they form as a new particle formation. So basically there are particles which are newly formed in the atmosphere from this mechanism. And then this, when these new particles are formed, these are even referred as a clean period. But then there is a growth and aging happened because of the reactions that is going on in the atmosphere. And then these particles uptake water and grow further, and then this causes most of this haze or smoke type of conditions. And then because of this hygroscopicity or ability of particle to absorb more water, or there are many inorganic species that attach to the surface of those particles, they grow further, they grow even bigger, and then they fame. This you see from this figure that these are the conditions referred as severe haze or smoke that we typically see in conditions like Delhi. And the other mechanism is they directly emit black carbon. So there's a chain of fractals you could see from the bottom half of this figure. And then these fractal aggregate, when they get aged, by the time they are present in the atmosphere, so this is the term aging refers to, and then they condense and they combine to form a kind of a circular or a spherical shape of the particle, where this kind of fractal aggregate is being in the form of this sphere. And then they get also aged, they get then inorganic or organic coating of the particles, and then those are mainly really highly hygroscopic, like having more water affinity. So then this particle grow bigger and bigger, and then reduces visibility, and then this is what we see during haze and smoke episodes. So these are the major kind of formation mechanisms, and then these aerosol play a very vital role in this. So this is again the kind of a slide that I have already talked about, but just to let you know why these aerosols are really important. So these are affecting in three different ways, like climate effects, the air quality effects, the health effects. So in the climate, it affects our energy budget of this planet Earth. It causes imbalance, either it cools or it warm. So it creates an imbalance in net cooling or net warming. So if you consider the case of black carbon or brown carbons, and we know that these are major warming factors, or those species that are causing mainly warming in our Earth's surface. And if you are talking about mainly those species like inorganics such as sulfate or nitrate, these are major factors that are coming into the net, that plays a part in net cooling or cooling. So basically, one of the species, when it increases its concentration in the atmosphere, then the sunlight interact and it causes more warming. So then it is imbalance. Either it's a net cooling or net warming, it creates a imbalance. Then there are effects on air quality, such as you see this figure from Delhi. So this is India Gate, and you could see that the conditions in October, November, December, these are mainly the hazy periods that we often experience during those periods due to variety of sources, local and transboundary from agriculture burning. And the other case is fog, like in January or something that we see fog. But nowadays it's more of smog, where the smoke is coupled with fog, and then it has severe health effects. And let's see in this next slide bit more understanding of the particle size, and then we see more like how these different size aggregated impact on human health. You can see from the left hand figure from US EPA. So they provided quite a nice demonstration, which you could have seen from in many different slides from experts. So you see that it's a 90 micrometer fine beach sand, and you compare the hair strand compared to the size of this fine beach sand, and you see this human hair is typically in the range of 50 to 70 micrometer. And then there are kind of five different blue dots that you could see that refers to a PM10. That is, that could be a size of a dust particle, pollen particle, mold, something like that. That is PM10 less than 10 micron in diameter. And within that circle, blue circle, you see four different tiny circles, spheres that could comprehend to the PM 2.5. Those are represented in pink color. So basically, these are the particles less than 2.5 micron in diameter, and this could be due to combustion particles, organic compounds, metal, etc., and etc. And then in the right panel, you could see that how these size segregated particles could have impact on human health. So you see those coarse particles, that is PM10, those basically resides only up inside the upper respiratory tract, as you've seen from this gray color, that they are mainly deposited due to the larger diameter on the upper respiratory tract. When they get finer and finer, they try to get more deeper inside the lungs, and then you see this PM 2.5 even goes inside the lungs, like in the lower respiratory tract, and harm this respiratory system or lungs. And when you talk about the PM1, they can even go deeper into alveoli. That is a kind of a fine, kind of a section in the lung from tracheobronchial and then to the alveoli region. Those are small tubes or globes that we have, that these fine particulates can go deep inside those alveoli. And when we talk about the ultrafine particle, that is 100 nanometer or PM 0.1, those are really, really, affecting our health, because that can go even inside the bloodstreams, that can affect nervous system, that can go to the brain, or so they can have a huge impact on entire human body. So that's why it's so important to get these checked, or to monitor, and then to make some policies in order to protect human health. Then let's just go more deep inside the kind of different air pollutants, their sources, the main kind of impact on health, and some of the guidelines from World Health Organization. So as I already mentioned, these can be from primary or secondary source. So this PM that can be released from the previous figure, if you could recall, it's mainly from primary and also from secondary when they interact with the kind of radicals and others. That's how these newly formed particles are generated. And the other source is direct emissions. So you already being aware that these are from road traffic, industries, construction activities, wood stores, mainly termed as man-made, anthropogenic, and then there are natural origin sources such as sea salt, dust, pollen, and then they have impact on cardiovascular, as I already mentioned, respiratory, cardiovascular, cancer, damage to nervous system, reproductive system, also seen in placenta of baby, like where the babies are. So all these have quite a big health hazards, and the range typically is PM 2.55 microgram per cubic meter annual. But in India, we are way, way less than this limit. Even the European countries are not in this limit. So they are also trying really hard to catch up to this limit. Then we have nitrogen oxides, nitrogen dioxide, and nitrogen oxide. So we have primary or secondary sources, mainly the anthropogenic sources, road dust, road traffic. Then we have natural, like night volcanoes, lightning strikes. They also have impact on inflammation, lungs, wheezing, asthma, heart disease, and this the limit is 10 microgram per cubic meter annual. Then we have ozone, primarily built from the secondary emissions, mainly the photochemical reaction. We'll see in the next slide of precursors and sunlight in the atmosphere, and then it also have problems. It also causes problems such as asthma, and apart from this also have huge damage to the ecosystem such as vegetation, crops, etc. And 60 microgram per cubic meter is the peak season average. And then we have carbon monoxide, sulfur dioxide. Both are primary emissions. Both are from combustion. So carbon monoxide is from incomplete combustions of carbonaceous fuels, and sulfur dioxide from combustion of fossil fuels, especially from power plants, homes, or industrial sectors. Both have issues, both can create issues in the short term for respiratory systems or also for brains, dizziness, confusion. So high exposure can even be more dangerous, and the limit is 4 milligram per cubic meter, and also 40 microgram per cubic meter for sulfur dioxide. Then we have other sources like, as you must be aware about those organic compounds or benzopyrene or PAHs, polycyclic aromatic hydrocarbons, also released from incomplete combustion, has registered impact on lung damage, worsening of asthma, lung diseases, cardiovascular diseases, and this European wide limit, because it's not many countries have this kind of limit, but European wide limit is 1 nanogram per cubic meter annual. And then you have metals. Those are also released from primary emissions, also from combustions. So basically, most of this is coming from primary emissions, especially apart from some of these gases that are secondary. So we can curb those things by having a strong policy and a kind of a feedback from government and a contribution from the residents. Then let's see those air pollution and health impact global scenarios. So just let me just quickly give you some of these recent examples of climate change and air pollution impact on human health. If you see in the left panel, the California case, where a 10 unit increase in wildfire related to PM 2.5 led to a 30% increase in hospital visits among children in 2021. And these wildfires, because of this climate change, these frequent wildfires occurring in those regions in California, and then this is causing quite a lot of hospital visits or sea conditions for children. You could see from the stat. Then, if you consider the case of Europe, then we've seen in Greece in 2021. Apart from that, there are many other small here and there these issues that are triggered mainly due to because of this heat wave that triggered wildfire, and also the desert dust that is coming from Sahara. So they all combined those wildfire and dust that resulted in, especially in the Greece in 2021, this episode, severe air quality. And we are seeing in Europe in these summer period, lot of these heat waves, intense heat waves are coming these days, even triggering the temperature to in 40s, which were never being seen before. So this is because of the climate change that is happening around us, and we are not much aware about that, but we are seeing it, right? So in Greece, it occurred due to that, but then in African cases, you see most of the time these temperatures are higher due to dust because of this natural, the Saharan dust is there, and then this also have significant risk factor in those areas. Then we see in China there is a case due to exposure of PM 2.5 and extreme temperature. They associated, and the study tell that there are higher risk of death. And even though China is trying to maintain its air or reduce the air pollution, but still the exposure to PM 2.5 is quite high, and that causes mainly this risk of death. Then you have a case in Uzbekistan also due to the the kind of severe dust storm, and it's a kind of a worst air quality in more than a century time. And that's why you see most of these parts, n- not only Asia, but Europe or American part or kind of African, nobody is being spared from this air pollution menace. So that is the main point of telling you the kind of impact that climate change and air pollution could have in total. So now we are aware about most of the basics, like what are the sources of pollution, climate change, how they impact our human health. Now let's see some of those real world scenarios or cases where these we have these recent episodes in terms of visualization. So you see in this figure, so this is mainly the figure captured during the severe haze in New York. So this is caused by wildfires, the Canadian wildfire that occurred a couple of years ago. And due to it, there was a severe emergency, and most of this created quite a lot of panic, and, and the hospitalization rate were increased, and it mainly affected the vulnerable population such as kids or adults or having earlier severe problems like asthma. So these kind of conditions, you don't have control of these situations, because now, because of the temperature increase, because of heat waves, those wildfire has occurred, and this Canadian wildfire, and you see this transboundary pollution coming to New York. So this pollution knows no boundaries. So it all is connected. Everything is connected, because of this air climate change. You see increase in heat heat waves, and that causes wildfire. That causes this kind of air pollution episodes. And then you see some kind of other kind of examples where you see this is a famous picture from Los Angeles, where this is mainly due to photochemical smoke. So this is mainly due to the impact of ozone, and that is being released, that is being formed from the release of nitrous oxides, and due to the local emissions or mainly traffic. Traffic is the main, and when it is combined with the meteorological scenarios, like where you have low boundary layer and something like that, all those conditions that when they met together, then this creates such a scenario. And let's see more about photochemical smoke so that you get more understanding. So photochemical smoke is primarily known as a brown haze, and you see variety of different sources. Then you see the mainly the primary pollutants in nitrous oxide, NO2, and then VOCs, volatile organic compounds. And this photochemical smoke actually refers to that type of smoke which is formed when the ultraviolet rays coming from sun reacts with the nitrogen oxides that are present in the atmosphere being released from the primary emission sources. And then you see from these equations that NO2 interact with the sunlight, then form NO plus O. And there is abundant oxygen. And then O, that O part is combined with ozone, with O2 oxygen, and then form ozone. And then ozone then again interact with NO to form oxygen and nitrogen oxide. So basically, this is a kind of a vicious circle where this again there is the NO2 form, NO2 again react with sunlight and again forms NO, then ozone. So these keep on going. So this is kind of a photochemical smoke that we refer to. And now let's see the case in Delhi. So Delhi, you see also the smog mainly in October, November is a severe time where most of these local sources interact with the transboundary source emitted particles from agriculture biomass burning. And then you have different sources already in Delhi, industrial pollution, you have trash or waste burning occurring. So these creates a kind of severe emergencies kind of situations or smoke chamber kind of situation, which Supreme Court has already mentioned, honorable Supreme Court has already mentioned in many of their hearings. But we see this on regular times, in all these years. This is happening so frequently during that period, that we are constantly in that higher amount of air pollution inhale intake. So let's see a new mechanisms that is being provided from this paper in Gunthe et al. In recent paper, where there's a new particle for kind of air pollution formation mechanism, where you don't see this kind of mechanism in many other countries, because most of these sources are not there, especially in African countries. But then there are not many studies that has been conducted to monitor that. But in India, we have seen this study presented a kind of evidence that those you see in the down panel, there are two different sources. So one is kind of a garbage burning or trash burning that you usually see around the streets or corners in Indian cities or in rural towns. And then on the second, on the left hand side, you see there's a kind of a pool of liquid that is chemicals. So basically, we have this hydrochloric acid, so this e-waste, so electronic waste. They try to take some kind of gold or silver that is plated, and they dip this in this pool of chemical, and then from this, when it's released, so basically they are these HCl or chloride is being emitted from these of the sources. And when these is emitted, this interact with ammonia. So basically, there's an abundant ammonia in the atmosphere because of those pesticides and livestock that is near to Delhi or other places in NCR, National Capital Region. And then you see that when there this HCl when is combined with NH3, so it form NH4Cl, that is ammonium chloride. So it happens basically from the co-condensation of chloride. So because of this kind of aqueous chemistry that is happening. And because this ammonium chloride is one of the highest water affinity particle or water absorbing particle, you see a bigger growth in this particle. And that's why if you see the role of relative humidity. So when the relative humidity is lower than 100%, then you see typically that condition is hazy. When it is greater than 100%, typically it's a condition of fog, and you see a poor visibility in both of the scenarios. So it mainly depends on the nighttime RH, because the RH relative humidity must be greater than 70% for that particle to grow. So because of that condensation phenomena, so basically there are two type of phenomena that occurs. So coagulation, so when the particles stick to each other and form a bigger particle, and then it uptakes water. And the secondary is the condensation, when there's a particle has a kind of a where this these gaseous species interact, and then it grows. So basically ammonia and chloride, then they interact each other and form ammonium chloride. So this is one of the crucial factor to see. And then it has also impact on, there are other gases, other reactions also occurring on when this M2O5 interact with NH4Cl, make ClNO2, and again interact with VOCs, again form ozone or secondary organic or aerosols, and then they again interact. So this is again the kind of a cycle that we are talking about in a photochemical reactions, that but here the chemistry or the processes are more complex compared to a photochemical chemistry, right? So these are some of these issues that we need to understand, that how these new mechanisms creating air pollution formation in these cities, and how we should be aware about these new challenges that are being present there in the current scenarios. Now, when we are aware about that, let's see what are those measurement techniques that are available for air pollution monitoring. So we knew quite a lot now from the overview of this air pollution, the mechanisms. Let's see what are those measurement techniques available. So in this figure, in the right panel, you see from the figure that there are a variety of different sources or techniques that are present for monitoring. So we see that there's a reference station. So most of the time, if you see in Delhi, nowadays it's been increased, if I may be correct, so it's around 20 to 30, 25 or something reference stations. But in most of the cities, there are not many reference stations. So there are hardly one or two reference stations. So this is the traditional air pollution monitoring technique that we see. uh, that is being often considered as one of the main monitoring type. So there you see a reference station where you have different type of instrument to measure gases, to measure particulate matter, to measure other aerosol properties like chemical and physical properties or black carbon. Then you have then you have these satellite based measurements. So satellite based measurements can also provide you the data from the AOD, the aerosol optical depth, from the kind of instrument that are attached to the satellite. From there, you could retrieve. So basically, you retrieve that data and then you calculate it, all those properties like PM2.5 concentration. But that is too coarse, and that could be visualized for a global scenario. But when you're talking about a citywide scale, these in the lower range of that atmospheric boundary layer where most of these processes happening, these are not quite adequate measures like satellite, or when there are really new hotspots emerging in the city or for the other part of city that does not represent a kind of a situation where the reference station is situated, then you have biases in measurement. And those are the kind of drawbacks, I could say, or limitations, I could say. Those are the limitations of these techniques or measurement approaches. But then these are still necessary. So what should we do? So we, depending on these portable instruments or nowadays availability of these new instruments that are small, compact, portable. So we made a few more arrangements to monitor air pollution that could be mobile monitoring. Mobile means you when you try to monitor around a city, all those corners you could see by attaching your sensors or instruments on bicycle, on a vehicle, like a van or a kind of a backpack when you walk. So all those things could be done, but then there's still gap in our understanding when we are talking about vertical scenarios. So why this vertical is important? Because of this model validation. So models, basically what the air quality model, what they take the data from the ground and they assume that it's equal around all the kind of within the atmospheric boundary layer. But this does not happen. So we'll see in later slide that why drone based measurements are important. And that's why we opt for these new type of measurements known as mobile measurements or drone based measurements in our scenario where there are already ground-based measurements and satellite-based measurements are available. So we are stating that we also need ground and satellite. That's why we term these measurements as a complementary approach to the existing measurement that is a traditional measurement, right? Because all in all, then we get a complete picture of air quality or air pollution on it, right? So then, because in this slide, the purpose is to give more insights on drones and how they are effective and useful in air pollution monitoring, climate change research, and adaptation. So we talk more about this in this slide. So before that, we need to understand what are those drone classifications. So there are, in this figure, you see there are variety of different type of drones that are being shown here. So in this figure, you could see, so these drones can be classified depending on the rotors. So basically, there are 4 rotors known as a quadcopter, there are 6 rotors known as hexcopters, 8 rotors or these blades that from where they can hover. So then there are 8 rotors, then you known as octocopter, right? Then you have all those you could see from figure. There are different type of drone from different companies, and then you also see in GE there's a kind of a helicopter shaped drone also. So that depends on your application, what you want to measure, what you want to monitor, at what site you want to monitor. So all these depends on kind of scientific objective you have. In the next slide, you could see there are also some different type of drones, like fixed wing drones, but majorly these are used in a climate change research or glacier monitoring, or you are monitoring in Antarctica, Arctic regions, where you want to do a kind of a horizontal and vertical monitoring both ways. But when you're talking about mainly those source pollution identification or kind of the citywide monitoring, you see from this figure that you see mainly those multi-rotor drones that you use. And those drones are equipped with air quality sensors, right? And these air quality sensors are then attached. So there could be gases sensors, there could be particulate matter sensors. We will see in the next slide more detail what kind of portable instruments nowadays available that could be coupled on board these drones. And from the right panel, you see that these are really handy in monitoring to the areas where a human being or other platform cannot reach. So these are some of the advantages that these drones-based payload attached to these drones have. And you monitor this industrial emissions or also some kind of disaster response when there's a kind of leakage in some industrial sectors. So you could just send your drone and that could let you know rather than sending some human assistance. So that could be harmful for those human beings. So all those way these drones are really handy. And also this landfill site or the inspection of those waste, all these way these drones are coming in these days quite applicable. Then we see after getting the information of the drones, like what kind of drones are available in the market these days and how powerful these are. Uh, then we're going to see mostly the kind of instruments, miniature instruments, or small, compact, handy instruments that are suitable for these drone-based applications. And let's see with the black carbon instrument. So black carbon is really important to understand in those areas, like the vertical profile of black carbon is really important to get the radiative impact. The optical properties of black carbon are important. And when you feed into the radiative model, the columnar properties are required. And that's why these small instruments, they are developed in a manner so that they could be easily coupled with drones so that you could do this vertical profiling. And these are really robust instruments. So there are a variety of different studies available where you see these are really powerful. They produce robust results. There are intercomparison studies around the world that they show that these are kind of comparable to those reference base stations monitors. So you could see from the lower panel the figure. This is an instrument from Maggie Scientific known as Micro Earth Model AE51. So this only works on one wavelength, but nowadays they also have some other instruments that works on 4 to 5 different wavelengths. That is known as MA200, 300, and 350. You could check from their website. So the main principle is the light source when interact in this wavelength 880 nanometer, and that there's a filter with 3 millimeter black carbon spot. And then when they interact, they radiate, they kind of reflect the energy, and this light detector, they actually absorb those, they detect those, and they provide the sensing eye. There's a value of those intensity, and then there is a reference intensity. And when you calculate using the formula given by Hansen in 1984, that black carbon is equal to 10 to the power 9 divided by sigma attenuation multiplied by area into attenuation divided by 100 into Q into delta T, where this BC or EBC is the mass concentration in nanogram per cubic meter. The A area is the area of that sample spot that I showed in the filter, where it interacted in meter square meter. Q is the volumetric flow rate in cubic meter per second. Delta T is the sampling time interval, and delta attenuation is that variation in the attenuation during that period delta T. And that sigma attenuation that we are talking about in this figure, that is being set as mass attenuation cross section 12.5 square meters divided by G. So basically this can also be changed. So there are studies which show that depending on the situation or the location, this could be changed, and this can easily be calculated and then fitted into the mode in the equation to calculate the mass concentration of BC. So this is quite important instrument, and when you attach this, you get the mass concentration of BC as well as the optical properties of black carbon, like attenuation. Then you have another instrument that is optical particle size spectrometer. So this is really important for particle number size distribution. and particle number concentration. How many particles are there in the atmosphere and what are their sizes? That is really important for the modeling. That's why I'm showing only these instruments, because that BC, black carbon information, particle number sizes information, and chemical composition, all these informations are being fed into the models for climate change research, for radiative property, for forcing analysis, for air quality models. So that's why these instruments are important. And you could see this is an instrument from TSI, and there are other also, there are new companies also that produces this kind of instruments. And you see for this specific instrument, the particle size range is from 0.3 to 10 micrometer. Size channels are 16. This is also have the same principle in the right hand side of the slide you see in the figure, that on the top there's the aerosol inlet of 1 liter per minute. When they interact with the laser light, so it's being scattered, and then it detected from the photo detector placed at 90-degree light collection, and then based on that you calculate from the similar kind of formula from Beer-Lambert law, I is equal to I naught, and then rest other area, flow, and all those things. When you know, you can calculate easily the mass concentration of or sorry, the particle size distribution or mass concentration or number concentration of those particles. Then after that, nowadays there are most of these new low cost particulate matter sensors are available in the market. As far as we know about India, so there are many different companies that are producing these small low cost sensors or instruments that are really handy to be placed for getting a special, more detailed special resolution. This could also be placed on drones to get real-time particulate matter PM2.5 information in vertical domain. And this is an instrument from Respirer Living Sciences, mostly used in our community, where this developed as Atmos instrument, where you could see from the similar kind of principle that I showed here, that aerosol inlet. So there's the inlet, particle are coming, interacting with the laser light, being scattered and detected by a photo detector, and then you see. But here, the only difference from the size spectrometer to this nephelometer or a low-cost particle matter sensor is that you do not have a luxury to get a particle size distribution, because they only get information of on the raw signal that calculate directly the mass from the equation. So in this instrument, this is more robust, where it provides you particle number, size distribution, concentration, and from that equation you calculate particle mass concentration. But here you only get particle mass concentration, that is PM 2.5, 1, and 10 in microgram per cubic meter. So these are really effective instruments for monitoring, like for mobile monitoring, for drone-based monitoring, or for spatial resolution enhancement. Then we knew about most of these low cost or portable or compact instruments that are available, but there is a really important protocol that we need to understand before putting it. So most of the time what people do, they directly put on the drone and then they fly, but that's not. So we are not getting a correct data because we are not adopting an effective sampling protocol. So what are those effective sampling protocols, and what are the problems or challenges that are associated when you are doing a drone-based air pollution monitoring using these miniature instruments? So you need to take into consideration three main impacts, three main kind of protocols. So the first is intercomparison experiment. Although people do that, they place their small low cost or instrument or compact instrument in front of a reference station at ground for 15 days. That is also required. But before doing your actual experiment, what you need to do, you need to install your instruments on board drone, like you see in this figure, but in a more compact manner that I show in the next slide. What they do is going to fly near to that to get actual feeling that while you are flying those instruments, what are the issues associated with the rotor, what are the issues associated with humidity. So all those things you are going to realize when you do such kind of intercomparison experiment. So in this figure, you see this is a UAV or drone. They are also referred as unmanned aerial vehicles. So this is from a DJI company. It's hovering over there. So there you see a kind of a weather station or a pollution monitoring station. And these are local air pollution sensors that are attached. But this figure, I'm just showing you to show the intercomparison experiment, but there are some limit or kind of issues associated with this kind of sampling because they haven't used kind of a good inlet uh, that that could minimize the rotor impact. They didn't use the humidity dehumidifier. So all those things, the issues we're going to touch in the next slides. Why it is so important? So if you clearly remember that the first step is to do the intercomparison at ground, the second step is to do the intercomparison while flying, and the third step is to do minimize the humidity impact, or we could say uh, that you put a dehumidifier in front of this. So I'm going to show you from a recent study, and we also use this in our experiment. So you see in the left panel that there is a drone, there's an instrument attached, and then you see a dryer. So it's written over, there's a long tube, and over that is a black, so it's being put inside that kind of a tube. So there's a dryer which based on silica gel basis, basically. So this is a diffusion dryer. So when the air is passed, so it's kind of a dehumidified, or the humidity impact is already minimized. And then when it interact with the particles in the laser light, it does not give you overestimation of those mass. So what happened with this kind of sensors in here? So when there's a high humid, or the particle is highly humid, and when it interact with this light, laser light, so it gives a false sense that you have higher mass because it already have a higher water intake on that. So that's for to minimize that and to have effective sampling, you should place a kind of a dryer in front of it so that you get a kind of better results that we typically do in a kind of a ground-based monitoring station. We do provide kind of a dryer in front of our sampling line. So all these techniques are already there, but the thing is that we also need to apply these on drones in order to get effective sampling. And then you see there are different cover cups they provided in order to protect from heat, other ways, these type of activities. And then on the right side, you see again the same kind of experiment here that I was telling. But the issue from this, as I already mentioned, was that they did not use any of those pipe or inlet line, or they did not even consider caring about those dehumidifier. And that's why if they do some such kind of scenario, they will not get a kind of a proper um, proper kind of from the reference station, the kind of calibration. But here they did it with a perfect approach where they did fly. Now in the second, in this right panel figure, you see there's a kind of a reference station. Now they are doing an intercomparison experiment, but before that they made sure that they are sending a humid free or a dried air to the sample, to the instrument. And the kind of inlet, why they put the dryer in top of that, we will explain in the next slide from another study. So it's being clearly visible from this study that there is a kind of a sampling tube that they placed a front of, like on the top of this kind of drone setup. And that is mainly due to why they did because of the minimization of rotor impact. So this propeller, when they are when this drone is flying, the propeller, they generate quite a lot of air, right? and and they create a kind of uncertainty in our measurement. But then in order to reduce that uncertainty because of those rotor impact, we are trying to take the sampling tube to that level where we have minimal impact of those rotors. And that's what you see in the previous studies here, and that you see in this study. But here you see they did not use a dryer, even though they are using the PM 2.5 units. So all in all, only one study we found is mainly using, so this is a study from Germany that I'm talking about. So this, they actually followed the entire protocol that is required to have effective sampling and to have the best or robust results while doing these kind of measurements. but even though they try to do something, but they still miss. Or maybe the condition could be in the manner where they are measuring the atmosphere in a summertime where there's not much humid. So that could also be a case in this study. So in that manner, you mainly need to consider the sampling tube as a protocol. But when you are considering a case like Delhi, or in a winter period measurement, or kind of a period where there is more fluctuation of humidity, there's a more humid atmosphere, then you need to take into consideration over dryer. Otherwise, in a summer period, you just go with the sampling tube, attach it in front of your instrument, and then measure the kind of properties or species. Now, when we are aware about all those three things that we need to memorize in our, or write down in our protocol, that these are the three methods or steps we need to incorporate, and also depending on the location conditions. But these are the three mainly for those humid conditions or smog or fog kind of measurement situations where the air pollution is more worse. So these are really important, really handy to note down. So then we will see the kind of case studies or successful drone deployments. So I have already shown you some of those results. Those are also kind of case studies. Uh, it's being reported in their paper. One was from Taiwan. This was from Taiwan. This was from Germany. This was from Poland. So after that, let me take you to those successful drone deployments in scenario of India, because most of the people also see that yes, in foreign countries there are different regulations, there are different conditions, different type of infrastructure, but would these drones deployment could be handy or effective in Indian scenarios or not? So let me show you some of those successful drone deployments in India. So you could see this is a really nice paper from Dubey et al. In 2022, which shows in Kolkata they did in near roadside. So there's a kind of a highway where they did some kind of drone measurements in order to get the vertical profile of those roadside dust or roadside particulate matter pollution concentration, based depending on the low cost sensor that they installed on the drone. So if you see on the left hand side, what they did, they took some of the ground measurements, ground data, and then they had this kind of a drone setup where this low cost sensor was placed, and then they did 100-meter vertical profiling and 80-meter horizontal flights. And then you see on the right panel, on the middle panel, there's a 100-meter vertical profile data. On the right panel, there's a horizontal flights data. So what they measured is they measured the PM1, 2.5, PM10 concentration along with the meteorological data like relative humidity and temperature. And then they also had this ground level reference instrument just to be sure that they are measuring correct values. What they see in the results is that some of the days they see higher concentration at higher altitude, and most of these other days they don't see such scenarios. So what these things refer to, so these refer to that when we do not have these kind of measurements, we don't know what is actual situation of those at higher altitudes. And these studies are really important for monitoring air pollution, for all those air quality forecasts, and all these data is really important because we now know that how these particulate matter are behaving up, away from the ground, what are those levels, and how they are really changing their concentration at different altitudes. Then we see another case study from Chennai. So I wrote the dump yard, but they also did in residential area, in industrial area, and dump yards, but they did majority in dump yards. So what they did, they selected three different study areas: dump yards, residential areas, and industrial areas, and then they put those local sensor on board drone, and then then they had a flights, different flights around these study areas. And what they did, they used kind of those monitor readings to a storage, And then what they did kind of a different prediction system analysis. So not only did they use the drones for calculating or measuring those pollutant concentrations, but they also applied some kind of a neural network or prediction system network, bi-gated current network, where they had different sources. And this kind of prediction system can then predict the output depending on the input that you fed. So so basically, what the forecast system does, so they take this ground-based data and then they do the forecast. But the vertical scenario is still missing. So all those vertical information, when you feed into the prediction system, that provides you more detailed or more robust predicted output as compared to just the traditional one. Then you see another case study from again the same author Dubey et al. In 2024 in West Bengal. And again, now he did the same near the highway, but then the impact of those tree canopy. So you see that there's a reference station that they placed is PM sensor OPC-N3, the grim one from the reference station at the ground, but then the OPC-N3, there's a PM sensor, the low-cost sensor that I showed in previous slide. So what they did like behind the tree canopy, near the road path, above up to 100 meter, and then they calculated the kind of reduction in the mean values, like what are on road data, like what they did in the previous study, and then behind the tree canopy. So then you could see easily the mean values which are represented in bold black color on road contributed because of the road dust, that the PM1 is 103, PM 2.5 is 116, PM10 is 155. But when you compare it with the mean values in blue bold colors, that these are significantly reduced. And because of this tree, the tree canopy, the PM1 is reduced to 29%. This is really important message that how we are going to tackle our pollution scenarios on this kind of situation where you have due to traffic, road dust, there are so many kind of so impactful sources contributing to air pollution, and how these simple approaches could reduce the levels of PM to this much of percentage. Then we see our case study in Delhi, which we did a couple of years ago. So this is our drone. So we use this Atmos PM monitor that I showed, loco sensor, and then the aethalometer also that I shown for measuring black carbon. There's a silica gel dryer that we put in front. There's a kind of a sampling inlet that we provided 0.36 meter in order to minimize the rotor impact. So all in all, we followed all those approaches in order to make effective sampling. The idea was to get the vertical information of air pollutants, black carbon. To do the model validation, we did some WRF model validation. Then the idea is to also understand the low-level haze formation understanding, like what are those factors that are creating or causing low-level haze. So I would just show you some of those results in this case study. So you see this our drone was hovering at a certain height, and you could see this is a backdrop kind of hazy in the morning. This is IIT Delhi site we did in 2021. And what you see is that there are different days that I mentioned in the right panel. So you could see that this is the altitude in y-axis, PM mass concentration in x-axis, and the color black represent PM1, red represent PM 2.5, and blue represent PM10. So you could see that there are different days, 18, 19, 20, and 22. Those are all early morning scenes. So basically we were focused on to understand hazy versus non-hazy mornings. So some day we have quite a lot of haze in the morning, the other day no. And then we could see the impact on 18th and 19th. If you compare those results, you see a kind of a line that is in red color, PM 2.5, And you see there is a continuous increase in the concentration of PM 2.5 as compared to the ground level. So if you see at the ground, it's 100, typically around 100 microgram per cubic meter, but it reaches all around 180 when it reaches at 100. So what is causing that? So basically there are temperature inversions, that this boundary layer is so stable and so shallow, so that most of these pollutants are being mixed there and then they are trapped. So when we measured at those heights, we got the right information of the pollutant, the mass concentration, the black carbon concentration, etc. On the other hand, on the other morning, we don't see such situation. Those conditions are known as known hazy. And why we say hazy, non-hazy? Because of we are referring to one of the paper where they say more than 130 microgram per cubic meter in urban scenarios. You see it typically rate as hazy, and then more than 180 or 200 rates as severe hazy, and then less than that non-hazy. So you see 110 something at ground, PM 2.5. Again, you see the red line, but then it keeps on decreasing, and you see around 80 something microgram per cubic meter, if you see compared to the previous 180, is significantly less. And those information, and similarly if you see in 20th, that there was kind of increase and then decrease and then increase and then decrease. So basically those increase at 60 70 meter on 20th was mainly because of that boundary layer shallow. It's so shallow at 70 meter that you even see those kind of layers, that within these 20 or 30 meter, there's this layer of pollutant that all those pollutants are trapped in that. And we got the information because we did this experiment. The next, on 22nd, because 21st was somehow some rain occurred, some rainy event, so it washed out most of the pollutant, and you see significant reduction in these air pollutant during this. And this red line is PM 2.5, again is 40 meter and is straight. There's no such variation according to the to the altitude. So what we trying to convey here is that when we try to do some kind of WRF chem modeling, or validation of those models, air quality model, we see that there was significant under estimation of those pollutant by WRF, because they did not have the information about this local formation. And why? Because the model only assumes whatever is present at the ground to the whole level. And within these 100 meters where the most of these pollutants are trapped, or it's mainly responsible for human health issues, we don't have the information. And that's how these instruments or these platforms are really handy to monitor, right? Then we, after getting more of these ideas from the case studies, why it's relevant for doing such scenarios or such air pollution monitoring using drones, we see some of the cases where they could also be handy for climate change research or climate adaptation. So you could see these drones. So in this panel, you see there are two images. Uh, One image, you can see that these are the drones that are monitoring a wildfire, and then later on there are the smoke afterwards. Then it is also kind of measuring those pollutants. Plus these drones are also handy in early detection of wildfires, because there are some algorithms generated. Because when we say, when we send these drones to those locations where the slight fires are occurring, and they could immediately take the data and tell and send to the server. And then using those new technologies like machine learning, artificial intelligence, based on the previous database that is being fed, they could be really handy in early detection of wildfires. But here they can also be handy in a response where they could try to get the information of kind of burnt area that is being burned, or what are the area that we need to do just to stop these fires from more spreading, like the case that is being happened in Los Angeles in the last month. You must be aware of that, and these drones were really handy in such kind of scenarios. So all in all, if you are researching what impact these wildfire cause to the atmosphere, smoke pollutant measurements, these drones are still handy. If you are talking about the disaster response, these are still handy. So all in all, for these kind of wildfire approaches or wildfire scenarios, these drones are really effective. Then when we are talking about a kind of some research on precision agriculture and sustainability, you see these kind of drones nowadays, and even our new government is providing more and more subsidies, and more pilots are being trained to operate on ground level. Even these technologies reaching to villages, and villagers are also welcoming such technology. So what happens is that you do multiple of different activities. So this is a kind of a chart from a paper that shows you that you could do soil management, automated irrigation system. You could share the data among the collaborative network, and there are multiple drones that could be able to perform the task, share the real-time data. You assess the health of those plants. You optimize the water and pesticide application, and all this loop where you have ease of maintenance. You then virtualize or minimize those farming processes through autonomous drones via those cloud technology or server technology that I was mentioning in the form of, in the case of uh, those wildfires. And then you exchange all those information just to identify where the substitution is required and then regenerate. So basically, this is a whole process. But then when we are talking about the kind of application these drones could have in precision agriculture and sustainability practices. And we could say that I already mentioned a crop monitoring could be a case that could be handy, irrigation management or kind of automated management of irrigation, pest and disease detection. This could also be done. Yield prediction. This is really important for a farmer. So these drones attached with the sensors or lidars, this could easily provide you the information about the yield and the weed detection. So all in all, this is quite handy approach. This is a very nice figure that I found, that how many things that could be done from this new technology and how this is contributing in the form of a sustainability practices in order to reduce the other practices that are being done previously in traditional form. Then uh, we see that these are really important in most of these aspects, like disaster response or wildfire scenarios or agriculture, which are really important for our as far as our pollution and other standards are concerned. Then we see some of the case studies, but then we need to also see what are the future trends and innovations. So you heard me talking about more AI and ML, that is artificial intelligence and machine learning in drone based monitoring, but let me just give you more detailed analysis of what I was talking about. Like, what is the main significance of this artificial intelligence in drone technology? So this slide mainly displays the advancement in drone technology by empowering the autonomous decision-making ability and processes, which include autonomy, which include predictive maintenance, situational awareness, data analysis, and swarm coordination. So now let's go one by one to see. So when we are talking about the predictive maintenance, like we anticipate the maintenance need, unexpected losses. We reduce then the operational cost through proactive maintenance. And then it makes a way to the situational awareness, which provides you the real-time data on environmental conditions that improves your decision-making ability through advanced sensing. When you have this information, you make those drones autonomous. That means they enable fully autonomous operation without human, and that increase operational efficiency and reduce the human error, the kind of error that is generated from traditional approaches. After all those things, this data is collected, is sent for the analysis, and this facilitates the real-time processing of and the data analysis, and it generates actionable insights and improve decision making. So you see, this is kind of a case that we see the use of AI in this technology in drone-based air pollution monitoring or other climate change research. But this AI, this kind of AI you have seen in your day-to-day life, where you are seeing that most of the gadgets that you wear for like tracking of your health, like Apple Watches or so, they also work on this AI-based system, and then they provide you data then you get the data insight, and then you improve your decision making. Okay, I need to do this much of steps this day, this much of steps this day to make my health more strong, to make myself more strong or more health conscious. So this type of approach, this artificial intelligence play a significant role in drone technology, and we see in future more and more AI assisted drones, so that reduces human efforts. Then we talk about swarm technology, that you heard me speaking more of these swarms. Swarms means a network of drone coordinated with a single user. So you could just operate these drones from one station, and when they are AI assisted, you don't need some personnel to fly those. They could be flown from one station, and they could be placed at various sites. If you could see from this very nice figure demonstrated by Motlag, that there are a variety of sources, and then some of the drones are tracking these ship-based emissions, plumes, some of our industrial pollutions, roadside, some are placed near to the surveillance. So all these drones are doing different activities, performing different tasks, and then they are storing the data in a one cloud center data storage, and then you do the analysis, as we see in the previous figure. These are all future-based technology that we are not currently seeing, but maybe in future when these technologies are advanced, when these sensors are more compact and robust, then you see more and more drones. And also there are many challenges that are hindering so far the progress of these drone based technology that we will discuss now. So what are those challenges and opportunities in drone-based monitoring? So again, Motlag et al. Is a very nice review paper. If somebody wants to have more impression on drone-based monitoring, you could go and check this. So you see that there are a variety of different challenges that we face nowadays. That is obstacle detection and avoidance. Like we don't know, like maybe sometimes there's an error or GPS malfunction, then you have detection, then they do not detect it and they cannot avoid it, and then there's a crash. Or so far energy consumption on the drones, like these drones just only hovers up to like 20-25 minutes. How well the new energy sources or new batteries are evolving in order to provide more lifetime, more endurance time to these drones. And then also communication and networking, drone swarming, all these are challenges so far. So one of the main challenges also is regulatory and societal implications. So regulatory bodies, we don't have a big structure so far. A handful of guide in 2021 was released from Indian government, but still there are so many loopholes and still so many hesitations from the and paperwork or bureaucracy that is hindering all those development. But in coming days, we see more and more smooth operations. You could see this example of the swarm drones from drone light shows nowadays. Even government is organizing these drone shows. So we could also see this in different sectors, right? This drone swarming technology in air pollution monitoring. So we could see in future, and that's why we see some of these opportunities that in future we'll be able to see. And the major thing is that we also then going to calculate or predict based on this air pollution sensing, multiple air pollution sensing at a city-wide scale. And we then see emission source detection, that is hotspot emission that we are talking about. So whenever there is a new kind of pollutant being released from those plumes or some event occurs, so this intelligent drone could go and reach and track and then provide you the information. Okay, there's a leakage or there's this event, burning event has happened, so that timely intervention could be processed. So all in all, I provided, so there are few key takeaways or conclusions from this lecture. So hope I am on time. These drone technologies, they provide a complementary approach to traditional air pollution monitoring. These are extremely effective in early detection of wildfire and climate-based research. These are handy in precision agriculture by adopting the sustainable practices. They are like organic farming. They are also handy when you follow those effective sampling protocols, and this provide you really robust results. And the future innovations such as artificial intelligence, miniaturization of instruments, compact instrument swarm technology can provide you unprecedented insights on air pollution and climate. And if there are some discussions or question and answers, then please let me know. This is my contact if you want to contact me. Yeah.
Thank you, sir, for your resourceful talk. Now the topic is open for discussion to the participants.
Should I stop sharing or they still want to see from some of the slides?
Participants, are you able to hear me? If you have any doubt, now you can ask to Dr. Rajit. Okay, I think your topic was so explanatory that
Thank you very much.
nobody.
But I do hope that there are some kind of insights from these technologies that participant could have. Probably in their future research, they could integrate these things. Yeah.
Okay, so um, now on behalf of the TICCAS participants, I would like to extend our sincere gratitude to Dr. Rajit for his insightful talk on drone technology. Sir, your exploration of the role of drone in monitoring air pollution and climate adaptation has provided us with valuable perspectives. Dr. Rajit critically highlighted both the challenges and opportunities that drone technology present in addressing environmental issues, particularly related to climate change. Sir, we are inspired by your vision and expertise, and we look forward to collaborating with you in future programs also. Thank you once again, sir.
Thank you for
Thank
the
you.
concluding remarks, and likewise, thank you for again calling me for this kind of opportunity, and hope the participant could get more information from this. Yeah, thank you very much.
Thank you, sir.
Thank you. Have a nice day. Bye.
Okay, bye, sir. So I think Dr. Gams joined with us. Hello, sir. Are you able to hear me? Okay, just I'm dropping a message to him. Okay, so today the second session will be addressed by Dr. Vinod Kumar Garg, and he is joining with shortly within 2 to 3 minutes. So I am requesting to all the participants to stay online, please. I'm requesting to all the participants, please wait for 2 to 3 minutes. The second session will be started at 3:30.
Dr. Raut, I guess there are no queries.
Already finished, ma'am, and
Yeah, and
we try to
when are we starting with the new session?
within 1 to 2 minutes.
Okay, the speaker has joined.
I think so, but he just joined before 45 minutes.
Yeah.
Sir have joined with us. Now we are going to start. I am just introducing Dr. Garg. Dr. Garg is working as a professor in the Department of Environmental Science and Technology, School of Environment and Earth Science in Central University of Punjab. And he is renowned for his expertise in water and wastewater pollution monitoring and abatement, solid waste management, pesticide pollution, heavy metal and radionuclides pollution, and radioecology. He has more than 32 years of research experience in the field of environmental science and technology, and some of the major projects handled by him are invasive alien species in Himalayan region, cost of around 5 crores, establishment of a radio ecology center in Guru Jambheshwar University of Science and Technology, Hisar, Haryana, cost around 5.11 crores, natural uranium in groundwater in some districts of Haryana, radon and thorium and gamma radiation level in 3 districts of Haryana, ecological risk assessment for a Nerora atomic power station, biomass mediated removal of textile dye from waste effluent and characterization of microbial costoria. He is live member of Biotech Research Society of India, Indian Science Congress Association, Indian Society of Wood Science, National Solid Waste Association of India, Indian Nuclear Society, Punjab Academy of Sciences, member working group on biological treatment of waste, life member International Solid Waste Association Austria, International Forum on Industrial Bioprocesses, France. Till date, he has guided 25 PhD scholars and 110 master students and published more than 250 research and review articles in various reputed national and international journals and conferences. Now I am inviting Sir to address this session on behalf of our participants.
Very good afternoon, Dr. Rao, Dr. Benita, and other colleagues which are present here today in this section. Before I start, I would like to thank this university, Markandeshwar University, Mullana, and the organizers for giving me this opportunity to share with you. Friends, today I am going to talk on a topic, and I have given the title to my presentation, Atom for Peace. Basically, this title I have borrowed from a presentation that was given in 1960 in the UN Assembly by the then US President Eisenhower, when he was talking that how atom can be used for the peaceful purposes. So today I will be talking something about radioactivity and how this radioactivity can be used for the development of mankind and to make the life easy of the mankind and that all. So friends, I would like to keep this in a discussion kind of mode. थोड़ा मैं बोलूंगा, थोड़ा आप बोलेंगे. We will have some discussion mode. I don't want like this. I keep on speaking for 90 minutes and that all. So I want to know from you, when I say radioactivity, what is the first word that is coming to your mind? Any participant, please. जब रेडियो एक्टिविटी में कहता हूं तो सबसे पहला कौन सा वर्ड आपके माइंड में आता है? Any participant? Anyone, please?
Madam Curie, the first woman to receive
Okay.
Nobel Prize of
Madam
radioactivity.
Curie. Anyone else?
Uranium.
Uranium. Anyone else?
Madam Curie.
वो तो हो गया, Madam Curie. तो anything else that is coming to your mind?
Gamma rays,
Madam?
X-rays, gamma rays.
X-rays, gamma rays. Okay. Anything else? One more person. I want to know. Okay, what is the first word that comes to your mind when I say radiation?
Emissions of particles.
Emission of particles. So friends, I have taken the views of the 5 participants, and one of them talked about who invented radioactivity, other talked about just a material, that is uranium, and some technical thing, but no one has talked about its peaceful application, where it can be used in our daily life or like that. It means that people don't know much, or we are never taught that there may be some peaceful applications of the radiations. So let me start with the Madam Curie. Radioactivity was discovered in 1896 by Henry Becquerel, Mr. Curie, and Madam Curie, and these all the 3 were awarded the first Nobel Prize of Physics in 1903. And then Madam Curie got another Nobel Prize after 8 years in 1911 in the field of chemistry for the discovery of radium and polonium. There were a total of 4 members in the family of Madam Curie. Madam Curie, her husband, daughter, and son-in-law. Yes, these were the 4 members in the family, and they got 5 Nobel Prizes in a span of about 30 years. 2 Nobel Prizes to the Madam Curie, 1 to the husband, 1 to the daughter, and 1 to the son-in-law. So if you are more interested, please read about this on the internet. You will get a lot of literature. And now I am sharing with you a presentation that I have prepared for this. Is this shared?
Yes, sir. But not in.
Is my slide moving? Can anybody
Yes,
confirm?
it is moving. It is moving, sir.
So friends, before we talk about radiation, before we talk about radioactivity and that all, we have to understand what is a radiation. Radiation is nothing but this is a form of energy like light, heat or light, and it can be emitted through space and matter. But next line is very important. It cannot be detected by any of our 5 senses. Why this line is important? If you want to do some kind of research on the radiation, or if you want to detect the radiation in your ambient environment or anywhere, you need equipment. Without that, we cannot we cannot work in the field of radiation. As far as nuclear radiations are concerned, you all know, अभी एक participant ने बताया भी था, these are emitted in the form of alpha particles, which are nothing but helium nuclei and positively charged, or in the form of beta particle, that is just like electron and having negative charge, and in the form of electromagnetic waves, which is not having any kind of charge. If you see this slide, this is what I was telling you, that these cannot be seen, cannot be smelled, cannot be tasted, cannot be felt, cannot be heard. We ultimately need the equipment if you want to work in the field of radiation. Friends, as far as radiations are concerned, radiations are a fact of life. You, me, we all, whosoever living on this earth, we all are living in an ocean of radiations, because we are exposed to the radiation from the sun and outer space. Lot of radiations are coming from sun and outer space. And you know, when the earth was formed, since then, radioactive materials are present in the earth. The radioactive materials which are present in the earth from the day the earth was formed, those radioactive materials are called as primordial radionuclides. So primordial radionuclides are present in the earth. Even the houses in which we are living, they also emit the radiation. Even the buildings which we work, they also emit radiation. Even the food which we eat, that also emit radiation. Even the air which we breathe, that also emit radiation. I want to know from you, can any of the participants tell me that how we get exposed to the radiation in our houses or in the buildings where we work? Any participant, please. So can anyone tell that how we are exposed to the radiations?
So there are various sources of radiation, like we go for X-ray. Similarly, ultraviolet radiation,
Yes.
whenever
Yeah.
agricultural workers, they do outdoor activities, they are exposed to UV radiation.
So you are
Similarly, other kind of radiations like mobile phone is
mobile. Madam, actually, I am not talking about outside radiation. I am talking inside the houses. And I am talking only about the nuclear radiations. That where from the nuclear radiations are coming in our houses. So let me tell you, because our houses are made up of what? Soil, stones, concrete, cement, bricks, ईंट पत्थर वगैरह वगैरह से ही तो हमारे घर और हमारी बिल्डिंग सभी बनी है. And I told you that earth contain primordial radionuclide. जमीन में है ही हैं ये. So these radionuclide come in the structure of our houses, also in the walls. And you know, there are two decay chains, two radioactive decay chains are constantly going on since the earth has formed. मिट्टी में दो रेडियोएक्टिव डीके चेन चली रही हैं जब से पृथ्वी बनी है. वन ऑफ देम स्टार्ट विद यूरेनियम 238, सेकंड वन स्टार्ट विद थोरियम 232. So when decay is there, that time different daughters are produced, and one of the daughter that is produced during that decay is radon. And radon is a gas. Now in the walls, in the floors, in the roof, everywhere the decay of radioactive materials is going on, and in that process radon gas is produced, and that radon gas cannot be retained by these walls. So ultimately that is emitted by the walls inside the houses as well as outside the houses. So radon is a major source inside our houses, inside our buildings. As far as our food is concerned, because all the food which we eat, that is grown in the soil, and cells, which are the, you can say, building block of all the living materials, they cannot differentiate between radioactive and non-radioactive elements, or they cannot differentiate between stable or unstable element. When I say stable, it means I am talking about those elements which are not disintegrating, and unstable, I'm talking those elements which disintegrate. Let me take the example of potassium 40. You know, those are from chemistry. You all might have studied that K39 is a stable element. But K39 always contain 0.012% of K40 with it. And K40 is a radioactive element. So plants will not be able to differentiate between K39 and K40, and they will take up K40 also with the K39. So that's why that radioactivity that is taken up by the plants, by the fruits, by the grains from the soil, that will come into our body. As far as air we breathe, so here we know that, as just now as I was talking, that radon gas is present. We breathe radon gas also along with the other gases, and some of the radionuclides may be present in the particulate matter, so which we breathe. That way also some of the radiations entering our body. So radiations are inescapable. We are living in an ocean of radiation. Friends, before moving further, we have to understand little bit about the radiations. Depending upon the wavelength, radiations have been divided into 7 categories. There are 7 different types of the radiations on the basis of wavelength. Will any participant tell me what is the relationship between wavelength and energy of the radiation? Any participant, please. What kind of relationship is there between energy and wavelength? Anyone, please?
Namaskar, sir.
Yes, ma'am. Yes, ma'am.
So it is inverse relation.
Yes, it is inverse relation. You are perfectly right. Inverse means longer the wavelength, smaller will be the energy, and smaller the wavelength, more will be the energy. So if you look upon this diagram which I have shown here, when we move from left to right, that time wavelength is decreasing, but energy is increasing. Friends, as far as these radiations are concerned, we use these all kind of radiations for one or the other purpose, even in our daily life. So we will have a discussion for a minute here. And I want to know from you, can anyone tell me that have you ever used the radio waves in your daily life? Any participant, please. रेडियो वेव का कभी कहीं पर यूज किया है आप लोगों ने? एनी पार्टिसिपेंट प्लीज? तो कभी गलती तो होगा, हम कौन सा किसी को गलत कह रहे हैं? जब तक डिस्कशन नहीं होगा, till that time there is no use of my talking.
Sir, communication, broadcasting.
Exactly. The mobile phones which you keep all the time with you, they all use radio waves, friends. So anyone, what about microwave? Have ever used microwave in our daily life? Any participant?
Sir, in kitchen.
Yes, I see.
In almost every kitchen is having a device that is called as microwave, and that microwave uses the microwave radiation. Can anybody tell me how microwaves are producing the heating effect? How these produce heating effect? गर्म कैसे करती हैं ये? Anyone, please?
Sir, conduction, microwave rays will conduct between the material like potato or anything else.
Okay. Anyone else? Friends, actually what the microwaves do, when these microwave radiation fall on the material which you have taken into your utensil and put in the microwave device, these are absorbed by the water, and that leads to the vibration of the water molecules. And from the vibration of the water molecules, that heat is generated, and that ultimately heat up the whole of the material which you have taken into your utensils. If you take any material, you know better than me, those use microwave, if your material is completely dried and you put that into your microwave device, I think that will not be heated up. Because water is not present over there. The presence of moisture is must if you are using the microwave. So, okay. And you might have seen a number of times on the WhatsApp, you get different kind of messages that microwave is not good, this is harmful. Nothing is like that. कुछ करती ही नहीं है ये, तो बेचारी पानी को हिलाती है, वाइब्रेट करती है, and that is generating the heat. So those are all are fake and nonsense messages. So have you ever used infrared in your daily life? Any participant, please? Which device at your home do you think is having infrared? Anyone?
Yes, mobile, TV remote. And AC
Exactly.
remotes.
बहुत बढ़िया. Remote TV remote is the best example of the use of infrared radiation in our daily life. And nowadays a number of night vision camera have come, and all those night vision camera also use infrared radiation. Visible radiation, you all know, we are using all the time to see the things. Can you tell me, have you ever used ultraviolet radiation in your daily life? घर में कहाँ UV हमने use किया? अभी कोई बता भी रहे थे एक participant UV के बारे में. Any participant, please, can you tell where UV you think is used in our daily life, in our houses?
Nowadays, it is basically used as tube in water purification units.
Exactly. You are very right, sir. Friends, almost every house is having some water treatment device. And these water treatment devices have 4 or 5 different kind of treatment. किसी में 4 होते हैं, किसी में 5, किसी में 7 भी होते हैं. तो अगर मैं सिंपल सा शुरू करूं, the very first treatment of the water in your water treatment device, that is a sand filter. एक रेत का filter होता है. That is to remove the particles. Second one is a carbon filter. Carbon filter is used to remove some dissolved compound and the odorous compound. ऐसे compound जो कि पानी में smell देते हैं, उनको remove करने के लिए होता है. Third one is a RO. एक membrane होती है to remove the dissolved kind of things. And उसके बाद एक nano filtration होता है. और उसके बाद एक RO, एक इसके अंदर एक UV light लगी होती है. And that UV light is used to kill the microbes. बाकी जितने treatment हैं, they all are removing either the dissolved or undissolved impurities. But UV light is used to remove the microorganism, to kill the microorganism. But here one question arises again. What is the wavelength of the radiation of the UV that is used in your this water treatment device? क्या लगता है आपको उसकी वेवलेंथ कितनी होती है? किसी को है आइडिया? Any participant, please? Okay, friends, जो अब आप देखिएगा, अगर मौका मिले आपको देखने का, पढ़िएगा, उसकी वेवलेंथ होती है 254 नैनोमीटर. 254 nanometer is the wavelength of the UV device that is used in your water treatment equipment at your home. If it is more than that time this will be giving less energy, and that energy is not sufficient to kill the microorganisms. So as and when you buy any water treatment device, always check the wavelength of that UV. The next is the X-ray. X-ray, you all know, is having a number of medical applications, and similarly gamma is having a number of applications in different spheres of life that I'll be discussing with you. Now friends, if I come back to the environmental radioactivity field, depending upon the energy, all radiations can be divided into 2 categories. One is the ionizing radiation, and second one are the non-ionizing radiations. Ionizing radiations are those radiations which, when absorbed by our body, they do the ionization of the biomolecules which are present in our body. And once they do the ionization of those biomolecules, those molecules are ionized, they start some reactions which are really not required in our body, and that become problematic. Whereas non-ionizing radiations are those radiations which are not having the sufficient energy to ionize the biomolecules, and the effects whatever caused by the non-ionizing radiations are not permanent but temporary. So 2 radiations, X-rays and gamma rays, these are the radiations which fall under the category of ionizing radiation. Now onward, whatever I'll be talking only about X-rays and gamma rays. Friends, what will be the effect of the radiation? That basically depend upon their penetration power. And I told in the very first slide that nuclear or atomic radiation, they are either alpha particle or beta particle or the gamma rays or X-rays, one and same thing. So alpha particle is nothing but is a helium nuclei, a nucleus of helium. This is positively charged, this is quite heavy, and it cannot travel much in the air, it cannot pass through paper, it cannot pass through skin. Similarly, it cannot pass through even the clothes which we are wearing. As far as beta particle is concerned, as I told, beta particle is nothing but an electron. It can pass through paper, it can pass through skin, it can pass through clothes, but it cannot pass through the light metals like aluminium, like tin, etc. But as far as gamma or X-rays are concerned, these can pass through these material, paper, skin, etc., or even through light metals, but these cannot pass through the heavy metals. As far as neutrons are concerned, they can even pass through the heavy metals, and if you want to stop the neutrons, that time you have to make a water column, some concrete column, or some paraffin wax column only, then these neutrons can be stopped. Friends, आपने जरूर देखा होगा कि जो रेडियोग्राफर एक्सरे करता है, he is wearing some apron, और जो वो एप्रन पहनता है, that apron contains the sheet of some metals. उसका जो कोट होता है उसमें कुछ metals की sheet रहती है. So can anybody can guess कि किस metal की sheet होती है उसके लैब कोट में और क्यों होती है? Anyone please? एक्सरे करने वाले के क्यों रहती है उसमें मेटल की शीट उसके कोट में?
Is it lead, sir?
Yeah, this is lead. लेड की शीट होती है वो, बिकॉज दैट इज ए हैवी मेटल, और वो इसलिए पहनता है क्योंकि उसको तो दिन में बहुत एक्सरे करने हैं. इफ ही विल नॉट वियर दिस ऑन, ही विल बी एक्सपोज टू लॉट ऑफ रेडिएशन, और तो थोड़े दिनों में ही मर जाएगा. सो टू प्रोटेक्ट हिमसेल्फ ही वियर ए एप्रन that contains the sheets of the lead. I think I'm clear about this. Friends, this slide is very important. Half-life is very important property of the radioactive materials, and with the help of half-life we can predict how much radioactivity is remaining in an environment. Let me give one example. One thing more before the example I want to tell. Half-life may be millions of years or billions of years, or this may be a fraction of a second. दूसरी बात जो मैं आपको बताना चाहता हूं इसमें कि what is half-life? Half-life is nothing but this is the time in which 1/2 of the radioactive atom decay to the half of the original value. मतलब ये एक टाइम है. Its unit may be second, its units may be minutes. टाइम इसका यूनिट है. वो टाइम जिसमें कि सपोज यू हैव टेकन 100 ग्राम ऑफ सम रेडियो एक्टिव मटीरियल, जितने में उसमें से 50 ग्राम डिके कर जाए, दैट टाइम 50% डिके कर जाए, दैट इज कॉल्ड एज हाफ लाइफ टाइम. तो अगर ये हर बार हाफ डिके करेगा, इफ दिस विल डिके 50% एट ईच हाफ लाइफ, तो ए स्टेज विल कम व्हेन इट्स लेवल्स विल बी वेरी वेरी लो. तो एक चीज तो बड़ी क्लियर है, इफ देयर इज एनी स्पिलेज ऑफ रेडियो एक्टिविटी, कहीं पे भी रेडियो एक्टिविटी अगर प्रेजेंट है, दैट विल नेवर बी जीरो, क्योंकि वो तो हाफ होती जाएगी, और जब भी हाफ होगी इट विल नेवर बी जीरो. बट द कंसंट्रेशन विल बी सो लो आफ्टर सर्टेन पीरियड, आफ्टर सर्टेन नंबर ऑफ हाफ लाइव्स, that will be so low that it will not be possible by any equipment to detect the radioactivity. So thus this property is used by the environmental radiologist or by environmental scientists to predict that how much radioactivity is remaining in the environment. At the bottom I have shown a graph, this diagram. This diagram depicts that if this is the, if you look on the left hand side, if this is the, you can say the darkness is indicating how much radioactivity is there, and after 10 half-life cycle this is just like this. So generally we presume that after 10 half-life cycles the radioactivity has gone below detection limit. So let me take one example from Hiroshima and Nagasaki. You know, Hiroshima and Nagasaki are in Japan, and some bombs were dropped over there. those bombs were containing uranium, and then fission of the uranium took place, and that produced some other radionuclide. And during fission, I will take only two uranium, this cesium-137 and strontium-90. Along with this cobalt-60, tritium, etc., many radionuclides were produced, many daughters were produced. But let me take cesium and strontium. So now in that environment of Hiroshima, of Nagasaki, cesium is present and strontium is present because these were produced from the fission of uranium due to that atom bomb that was dropped over there. And the half-life of these two is approximately 30 years. 30 साल का इनका हाफ लाइफ है। तो आपको क्या लगता है, जो अभी तक हमने डिस्कशन किया है, कितने साल में, in how many years, the levels of cesium and strontium in Hiroshima and Nagasaki will be below detection limit? Any participant, please. कितने साल में आपको लगता है ये वहां से मतलब बिलो डिटेक्शन लिमिट चले जाएंगे? Any participant?
So 300 years.
300 years. You are very right. क्योंकि एक half life cycle is of 30 years and 10 half life cycles are of 30 into 10, that is equivalent to 300 years. यानी लगभग 300 साल उसको वहां से जाने में लगेगा. And by till 300 years, there will be some radioactivity, and the population living over there, that will always be exposed to those radiation. Now I give you another example. There was one accident in Fukushima, that is also in Japan. Due to the tsunami, some radioactivity was released from the Fukushima nuclear power plant, and from that iodine-131 was released, and the half-life of iodine-131 is 8.01 days. So friends, in how many days you think radioactivity will be below detection limit? Any participant, please? Anyone? A very simple question. 8 point. Pardon?
Then what was the half-life?
8.01 days.
So 80.1.
80, yes, 80 or 81 days, roughly मोटा मोटा हम कह सकते हैं. So in 80s or 81 days, this will be very below detection limit. So you can see how long the radioactivity is going to stay in a particular environment. That will be depending upon the half-life of that particular radionuclide, and as I told you, that is variable from millions and billions of years to a fraction of second. Friends, just now I told you that since the Earth has formed, two radioactive decay chains are going on in the Earth. One start with uranium-238 and second one start with thorium-232. These two decay chains are constantly going on in the Earth. And these both the decay chain, they end up in which element? Can anybody tell me after reading from here? So what is the last stable element of this series?
So lead-206.
Lead. Yes, both decay chain ultimately end up into the lead. Here we have lead-206 isotope and here we have lead-208 isotope. And if you look here on the half-life, you will be surprised to know that half-life of one of the element, that is uranium-238, is 4.47 billion years, whereas half-life of polonium is polonium-214 is 0.000164 second. किसी का दिनों में है, किसी का घंटों में है, like this. Okay, if I move little ahead, friends, the natural uranium which we get in the nature, जो हमें जमीन से मिलता है uranium, that uranium has three isotopes: uranium-238, uranium-235, and uranium-234. These are the isotopes of uranium which are present in the natural uranium. And natural uranium contain 99.3% of uranium-238, 0.72% of uranium-235, and 0.006% of the uranium-234. And here I have shown the specific activity. Here I would like to tell you one thing, that the nuclear power plants, in India, they all are using the natural uranium as fuel to produce the electricity. सभी में uranium का use होता है to produce the electricity. But out of these three isotopes, only uranium-235 isotope is used by the nuclear power plants. Remaining two are not used. Reason being, the activity of uranium-238 is very low, and if this is used, the reaction will not be sustainable. If we use uranium-234, its radioactivity is very, very high, and this reaction will be beyond our control. Things may go very violent. That's why uranium-235, our reactors are designed so that uranium-235 is used as a fuel, and the remaining two isotopes are not used as a fuel. Okay, friends, as far as the sources of the radiations are concerned, that where from we are getting the exposure to the radiation like any other pollutant. There are two sources of the ionizing radiation, natural, in the radiation which we are getting from the nature, as well as anthropogenic reasons. Okay, friends, according to United Nations Scientific Committee on Environmental Atomic Radiation, according to this is very important. The average global radiation dose, average dose which people get from the natural sources, that is 2.4 millisievert per year. Remember this, the average dose which people get is 2.4 millisievert from the natural sources. Now a question may be coming to your mind, that where from this 2.4 millisievert per year radiations we are getting. So friends, 50% of this 2.4 millisievert we get from a single source, that is the radon gas. And I just now told you that where from we get the radon gas. About 0.4 millisievert per year radiation dose we get from the sun and the cosmos, or from the atmosphere. About 0.5 millisievert radiation dose we get from the terrestrial sources. Terrestrial means I'm talking about the earth, houses and that all. And about 0.3 millisievert per year radiation dose we get from the internal sources. As I just now I had explained you that we take food, and that food contain radioactive material like K40, so they are present in our body, so they also emitting some radiation. तो ये तीन चार चीजें हैं जहां से मेजर हमें रेडियोएक्टिविटी का डोज मिलता है नेचुरल, और ये जो है 2.4 millisievert is the average dose of the radiation which we get. So friends, there may be some man-made sources. If I talk about man-made sources, the global average which we get from the medical diagnostics जो हम करते हैं कराते हैं 0.4 millisievert, and the nuclear testing that has been done in the past by a number of countries. During the nuclear testing, lot of activity has gone to the environment. और जैसा मैंने अभी बताया ना कि वो रेडियो एक्टिविटी एनवायरमेंट में गया, वो रेडियो न्यूक्लियाइड गए, तो वो तो भाई खत्म होते होते होंगे डिपेंडिंग अपॉन व्हाट आर द डॉटर्स. तो फ्रॉम दैट आल्सो वी आर गेटिंग सम डोज. You know, a Chernobyl accident that happened in 1984 in the then Russia, now in Ukraine. Some dose we get from that also. And even the nuclear power production, which we do, a very small dose we get from that. Means if we compare the natural and man-made sources, one thing is very clear, that about 85% of the radiation dose we get from the natural sources. Basically, this is what I wanted to say. जितना भी हमें radiation का dose मिलता है, उसमें से 85% हमारा जो आता है वो natural से आता है. About 14% is from the medical exposure. About 0.1% is from the nuclear power production, which we are doing all over the world. 0.1% is from the Chernobyl accident, as I explained just now. And about 0.2% from the weapon testing that has been done in the past by the people. But if I come to the Indian scenario, this medical exposure is only 2% to the Indian population. बहुत कम है Indian population में medical exposure. So if this exposure is less, then the natural sources contribution to the Indian population is about 97 or 97% approximately. The Indian population को global average 85% है natural sources से, Indian को जो है वो इससे 97% जो है वो natural है. Okay, This is a very interesting slide. There is a person, he's sitting in his house and he's saying that I am sitting in my house and I am safe from the radiation. No nuclear radiation, no this ionizing radiation can come to me. So I want to know from you friends, he is right or wrong? Usko radiation dose milega ya nahi milega? Anyone please? अपने घर में बैठा है, सोच रहा है मुझे कोई रेडिएशन नहीं आएंगे, आई एम सेफ, बट व्हाट यू थिंक अबाउट हिम? He will get radiations or not?
मिलेगा sir.
Because where from he will get the radiation dose?
Concrete radon.
कंक्रीट से मिलेगा, बिल्कुल सही कह रही हैं आप. हाँ,
से मिलेगा, सॉइल से,
सॉइल से मिलेगा. हाँ,
फूड से मिलेगा सर.
फूड से मिलेगा. हाँ, नहीं घर में बैठा है उस टाइम पे, फूड नहीं खा रहा मान लो, तब उसकी बॉडी में से खुद ही खुद आएगा ना, इंटरनल भी होगा. द एयर विच ही इनहेलिंग, उससे भी आएगा. इवन द कॉस्मिक रेडिएशन विच आर कमिंग फ्रॉम द सन, they will also be giving him some radiation dose. जब एक बड़ा theoretical सा क्वेश्चन पूछता हूँ, suppose you want to make a house which is having zero radiation, कैसे बनाओगे ऐसा हाउस? किस चीज का बनाओगे वो हाउस? वेरी theoretical क्वेश्चन है ये. Anyone please? अभी हमने डिस्कस किया था एक जो उसको रोक लेता है. I think he can make a house of the lead. Yes or not? कि कहीं से कुछ आएगा ही नहीं, पर that is only theoretical, that is practically not possible. Friends, in this slide, I have shown that how much radiation we get in different cities. Because in different cities, we have different cosmos, we have different soil. So that's why people living in that area, they get a different radiation dose. So here I have shown that presently maximum radiation dose is to the Bangalore population and minimum is to the Mumbai population. But let me tell you, don't go by this number 480, 48110. Because these are very, very small units. This is in micro level units. So no need to worry. If you get worried, don't. So if a person is moving Mumbai to Bangalore, certainly he is going to get more radiation dose. Okay. Yes, a lot of research material, you will find that people have done a lot of studies on different kind of materials, building materials, which are used in India to make the houses. And people have tried to find out the radioactivity in those. So basically what I want to tell you through this data, that if you look upon K40 or any, you will find the range is very high. In different cements, K40 is present from 5 to 385 becquerel per kilogram. Similarly, you take any material, there is a very wide range. Basically what I want to say you, that if we take just sample of a cement or some brick or stone or some fly ash, etc., from one place, suppose we take from Bhatinda and we study building material in Bhatinda, and we say these are the levels, the same levels will not be applicable for Mullana or for your place. You have to do your study, only then you can find out what is the radioactivity in your building material. Means the study of one place cannot be the reference for other place, as we have seen in this slide, because the radiation scenario is totally different at different places. So what we can conclude from this, if we are really interested to know, then we have to do the micro level studies at every place, only then we will have the real picture. Friend, these are some of the area of the world where we have the maximum radiation, natural radiation levels. The maximum natural radiations are found at a place called as Guarapari, that is in Brazil, and the radiation dose over there is 24.5 millisievert, and that is about 10 times more than the global average. In India, maximum radiation dose is in Kerala, because Kerala sands contain a ore that is monazite, and monazite is a ore of thorium. As I told you, this is a ore of thorium 232, and that's why Kerala is having the highest radiation dose. Okay. Then, friends, little bit data I have shown here for the different kind of food materials which we eat. They also contain radioactivity. Again, my idea or showing of this slide is to tell to you the study done on the rice of Batinda or on the vegetable of Batinda may not be a reference for Mullana or for your place, wherever you are staying or living. So if you are interested into your material, you have to do the study at your level, because what will be the radioactivity in plants of a particular area, that will depend upon the kind of soil, the kind of varieties, the kind of farming practices adopted by the farmers over there. So these all contribute to this fact. Friends, there is a global project. The name of that global project is ZIRMON, GERMON. Basically, ZIRMON is Global Environmental Radioactivity Monitoring Program. IAEA has started this project. IAEA is International Atomic Energy Agency, that is in Vienna. They have started this project, and they want to have the real-time levels of the radioactivity in the environment. कि वो रियल टाइम एनवायरनमेंट में बैकग्राउंड लेवल कितने हैं ये हमें पता होना चाहिए. उसके लिए एक प्रोजेक्ट शुरू किया गया जिरमोन, एंड इन रिस्पॉन्स टू जिरमोन, Government of India asked BARC, Bhabha Atomic Research Center, to start a program, and the Bhabha Atomic Research Center has started a program. The name of that program for environmental radioactivity monitoring started by Bhabha Atomic Research Center is IRMON. IRMON, IERMON. IRMON is Indian Environmental Radioactivity Monitoring Program. Under this program, 550 IRMONs, IRMON is an instrument, have been installed at different places. And let me show you the picture of IRMON. This is IRMON. You can see, and this is, we are part of this program, and this is installed on the roof of our lab. And this IRMON is having a detector. The GM counter is present in it, and that GM counter is counting the radioactivity in the ambient environment. And this IRMON is having one mobile chip also. And through that mobile chip, that data is going to the Bhabha Atomic Research Center. You can see this wire. This wire is going into my lab and connected to a computer. And over there also, we are getting the real-time data of the IRMON, of this radiation. And if you see this, I have taken a screenshot of the computer that is in my lab at Hisar. You can see this graph. In this graph, you will find that we are getting the real-time levels of the ambient environmental radiation after every 5 minutes. And this is saying that this is the dose rate, 163 nanogram per hour is the dose rate which people are getting over there. And it is indicating this is a normal data. It's a normal data. So, but a question may be coming to your mind, that when we will call this is a abnormal data. So friends, whenever the value is double or more than the double than the normal value, then generally we say that the abnormal data. Abnormal data means, what is the meaning of abnormal data? Abnormal data means that there is some activity going on in the vicinity of this instrument that is containing the radioactivity. Means कुछ ना कुछ ऐसा हो रहा है आसपास में जिसके अंदर की रेडियो एक्टिविटी का यूज कर रहे हैं लोग. So this information we can have. So please read about the IRMON project. This is a wonderful project that has been started by Government of India for VP. Friends, many people talk about cancer which we can get from the radiation. Here I have shown that what is the probability of the fatal cancer which a population can have after getting a dose of 1 sievert. So can you tell me, based upon this table, can you tell me, let me explain first. So friends, for example, let me take the example of bladder. Bladder, the risk factor of bladder is 0.003. So what we conclude from this risk factor, we can say that if a population is exposed to a radiation dose of 1 sievert, then there is a probability that 3 out of 1000 may get bladder cancer, and that may be fatal. So now, friends, based upon this table, can you tell me which is the most sensitive part of our body with respect to the radiation dose? Yes, friends.
Sir, colon and
Colon and lung cancer.
Colon or lungs are very sensitive, because if a population of 1000 is exposed to this 1 sievert dose, there is a chances that 8.5 people may get this fatal cancer. And which body part you find are the most, you can say, having very strong and can tolerate this 1 sievert dose? Means which part will be having the lesser effect, rather, if I
Skin.
say skin. So can you interpret, sir, what is the meaning of 0.0002? What is the meaning of this?
2 out of 10,000.
Yes, yes, he's very right that if a population of 10,000 is exposed to this 1 millisievert radiation, then 2 may have skin cancer, that may be fatal. पर उससे पहले तो बहुत कुछ और हो जाएगा, सर, देख रहे हो ना, काफी कुछ हो जाएगा उससे पहले तो. Okay, so friend, this was the information, something about radiation. Now, as far as atomic radiations are concerned, they have lot of applications. Friends, I will talk about the 3, you can say, आप project कहिए, कुछ भी कहिए, target कहिए, which are based upon certain times. They are having some timeline. One of them is the Sustainable Development Goals. You know, there are 17 Sustainable Development Goals, and they contain number of things. And the target for Sustainable Development Goals is 2030. Similarly, all the time nowadays in India, we are talking Viksit Bharat at the rate of 2047 के 2047 में 100 years after independence हमारा देश विकसित होगा. Third target is in COP26, the Conference of Parties 26, that was held at Glasgow in November 2021, October-November 2021 में हुआ. And the main theme of that conference was reduction of the temperature, reduction of the temperature of the earth to 1.5 degree Celsius of the pre-industrial era. ये था ना कि उसको हम कम करेंगे टेम्परेचर को. And then Honorable Prime Minister Modi ji was there, and he had promised to the world in his talk that by 2070, यानी उन्होंने 50 साल का टारगेट लिया था, we will be a net zero carbon emission country. Net zero carbon emitting country के हमारा carbon emission zero होगा 2070 में, and our contribution will be zero to the climate change. So in all these 3 targets, these timelines, nuclear can play an important role, as well as so now onward I'll be talking in the light of these timelines and the applications of the nuclear atomic energy. So friends, we all know that we need electricity in our life, and it is said at many places the electricity which you consume is directly proportional to the degree of development of any nation. जितना हम बिजली कंज्यूम करते हैं वो इंडिकेट करती है कि how developed a nation is. So this diagram shows per capita energy consumption by the residents of different countries in a year. So the maximum energy presently is used by the Norwegian population, followed by Canada and USA. I know that they are consuming more energy for the heating of their houses. But can you see anywhere India in this consumption list, sir? India is there or not? Can anybody tell me?
it is there.
कहाँ को है जी?
ये सर पीछे से 5 नंबर पे.
पीछे से 5वां है. So if we compare Indian with some Japan, France or Germany people, our consumption of electricity is very, very low per capita. So do you think when we will be developed, certainly our energy consumption will be more? बिजली का तो यूज बढ़ेगा ही बढ़ेगा. जब हम 2047 में अपने आप को विकसित होने की बात कर रहे हैं, ये तो बढ़ेगा. तो फॉर दैट वी नीड इलेक्ट्रिसिटी. अब अगर वो इलेक्ट्रिसिटी मैं कोयले से बनाता हूं तो दैट टारगेट ऑफ 2070 will not be fulfilled, sustainable development goals will not be fulfilled. तो ये बहुत सारी कॉम्प्लिकेटेड चीजें हैं, इनके बारे में अभी बात करेंगे. रिसेंटली अगर आपने बजट सुना होगा, so honorable finance minister has said that by 2047 we will be producing 100 gigawatt electricity from the nuclear. It's a very big dream target which they have given to themselves, as well as the another target they have given that we will be using the small modular reactors for the production of electricity. ये थोड़ा मैं अभी explain करूंगा 2 मिनट के बाद. What are these SMRs and this all? Friends, already we are 8 billion population. हम हैं, but a large population, about 50% of the world population is living below poverty line. In this scenario, what are the energy options available to us? One is the fossil fuel, koila, tail, वगैरह. Second is the nuclear. Then we have the renewable sources available to us. And these renewable sources may be solar, maybe wind, maybe hydro, maybe geothermal. As a student of environmental sciences, I would like to tell you that geothermal is considered as the cleanest form of energy. Then this is solar, then this is nuclear, then hydro. And the most polluting among these all is fossil fuel. And you all know about 70% of the electricity we produce from the fossil fuels. जो सबसे ज्यादा पोल्यूट करता है उसी से हम सबसे ज्यादा इलेक्ट्रिसिटी प्रोड्यूस करते हैं. As far as hydro is concerned, friends, hydro is a very good, you can say, option before us. But in case of hydro, there are site issues. Hydro cannot be produced at all the sites, as well as there are transmission issues. Presently, about 3% of the total electricity which we produce, about 3% of that is produced from the nuclear sources. And friends, with the passage of time, this percentage is not going to increase, because the time in which we have one nuclear power plant, in the same time we can have the 10 thermal power plants which are based on the coal. तो वो percentage कभी बढ़ेगा भी नहीं. But every dark cloud is having a silver lining. तो अगर मैं बात करूं न्यूक्लियर की, friends, resources are available to us, means fuel is available to us in the form of uranium and thorium. Technology is available to us. Certainly this is a clean form of energy. If we will go for nuclear in future, certainly that carbon dioxide emission that is taking place due to the usage of fossil fuel for the production of electricity वो कम होगा, and we will be able to achieve those targets of 2070 which we have promised to the world. And this is not site specific. We can have nuclear power plant at any place. Energy efficiency is very high, and this is certainly a cheaper form of energy. Friends, here I have shown the efficiency of different kind of fuels. From 1 kilogram of wood, we can produce only 1 kilowatt of electricity. And from 1 kg of coal, we can produce 3 to 4 kilowatt hours, depending upon the type of coal. From 1 kg of oil, we can produce approximately 4 kilowatt hours of electricity. But from 1 kg of uranium, we can produce 3.5 million kilowatts of electricity. So this table shows that this is having very high efficiency. Now, if I come to the carbon dioxide emission, here I have shown comparison of fossil fuels with the nuclear. If we produce 1 gigawatt electricity that time using coal, if we produce 1 gigawatt of electricity using coal, that time about 800 to 900 tons of carbon dioxide is produced, which is very, very high. From oil, about 750 tons of carbon dioxide is produced for 1 gigawatt of electricity. And from gas, natural gas, about 500 tons of carbon dioxide is produced for 1 gigawatt of electricity. But from nuclear, if we use nuclear, that time carbon emission is very, very less, almost negligible. So that's why this particular year, Government of India has taken this target of producing 100 gigawatt of electricity from the nuclear, because when we will be using the nuclear as source of electricity, this carbon dioxide emission will be reduced. And when this carbon dioxide emission will be reduced, we will be able to achieve those promises which we have made to the world for 2070. So friends, this graph shows the present nuclear energy scenario of the world. If I take in terms of megawatt, maximum electricity from nuclear is produced in USA, but I will be talking about France. In France, the total electricity produced from nuclear is less than USA, but France is producing about 70% of its total electricity from the nuclear. जितनी बिजली वो बनाते हैं उसका 70% जो है वो न्यूक्लियर से बनाते हैं. एज फार एज इंडिया इज कंसर्न्ड, इन इंडिया वी हैव 8180 मेगावाट इंस्टॉल्ड कैपेसिटी. हमारे पास 8180 मेगावाट की टोटल इंस्टॉल्ड कैपेसिटी है. आई एम emphasizing the word installed capacity because most of our plants are not running more than 50 to 60% of their installed capacity. तो जो बिजली बनाते हैं वो उनकी installed capacity से कम बना रहे हैं. Okay, friends, this diagram shows that what is the position and that all of the nuclear station. Presently in India, we have 7 nuclear power stations. 7 स्टेशन है. And in these stations, we have a total of 24 nuclear reactors in India. 24 हमारे पास रिएक्टर हैं which are used to produce the electricity. ये बात याद रखिएगा. अभी 7 हमारे पास स्टेशन है, 24 हमारे पास रिएक्टर हैं. And these reactors are of different capacity. Some are of 100 megawatt capacity, some of 200, some of 220, some are of 160. And some are of 1000 megawatt capacity. But now India has developed the indigenous technology, and now onward government of India has taken a decision that whatever reactor we will use, we will have 2 type of reactors now onward. Either we will have SMR means small modular reactors, or we will have the traditional nuclear power plant. So whatever traditional nuclear power plant जो हम लगाएंगे अब now onward, and the reactor which we will have over there, they all will be of 700 megawatt capacity. Now then, what is SMR? What is a small modular reactor? SMR is a reactor which produce less than 300 megawatt electricity. 300 megawatt से नीचे जो electricity बनाता है, that is called as small न्यूक्लियर रिएक्टर, स्मॉल मॉड्यूलर रिएक्टर, और ऊपर जो बनाएगा उसको वो ट्रेडिशनल रिएक्टर होगा हमारा. इन हर बजट भाषण, फाइनेंस मिनिस्टर सेड दैट बाय 2033 वी विल हैव एट लीस्ट 5 एसएमआर इन इंडिया. कि भारत में हम 5 एसएमआर लगाएंगे. अभी तक तो टोटल हमारे पास 24 रिएक्टर है इतने साल में. आई डोंट नो हाउ वी विल गेट द 5 एसएमआर इन नेक्स्ट 5 ईयर, बिकॉज वर्ल्ड इज नॉट हैविंग मच एक्सपीरियंस ऑफ द एसएमआर्स. दुनिया के पास कोई एक्सपीरियंस नहीं है. देयर आर हार्डली 1 or 2 SMRs in the world which are presently operating in the world. And according to scientists, the minimum time that is required for the installation of a SMR is 56 months. 26 महीने का टाइम लगता है SMR के लिए. प्राइम मिनिस्टर ने हमारी, मेरे ख्याल आप देख लो कितना टाइम दिया है, 8 साल कुछ टाइम दिया होगा, 80-100 महीने का. But there is one company of South Africa. That company claimed that we can install a SMR in 24 months. अभी आने वाला टाइम बताएगा how the things will go. So friends, these are the pictures of the different nuclear power stations. This is Tarapur, this is Rajasthan, और ये रावत भाटा हुआ, ये मद्रास कलपक्कम हुआ, ये कैगा हुआ. ये जो मैंने यहाँ दिखाए थे ये उन्हीं के हैं सारे के सारे इमेजेस. और ये जो लास्ट वाला है, you might have seen it on TV in different kind of newspapers. Can anybody tell me, ये वाला जो picture है, this is of which nuclear power station? Any participant please? ये किस न्यूक्लियर पावर स्टेशन का है ये पिक्चर? देखा हो अगर आपने इसको. ओके, दिस इज ऑफ कुडनकुलम. ये जो लास्ट में तमिलनाडु में जो कुडनकुलम है, ये यहाँ पे लगे हुए हैं 2 रिएक्टर. दोनों वी हैव इंस्टॉल्ड विद द हेल्प ऑफ रशिया, एंड दीज आर ऑफ 1000 मेगावाट कैपेसिटी. अब सारा एक खत्म हो जाएगा अलग अलग. नाउ ऑनवर्ड वी विल हैव ओनली ऑफ either a SMR or of 700 megawatt capacity. So friends, and nuclear power plants जो हैं उनका construction, or you can say they have been planned at a number of locations. One has been planned in Haryana. ये जो एक गोरखपुर नीचे वाली टेबल में आप देखेंगे, there is one place गोरखपुर. गोरखपुर is nothing but a small village of Fatehpur district. Earlier this was in Hisar district. The district divided into two. Now it has come in Fatehpur district. तो यहाँ पे 4 रिएक्टर लगेंगे और 700 मेगावाट कैपेसिटी के लगेंगे. And similarly, for these nuclear power plants, friends, we need fuel. Fuel की भी जरूरत पड़ेगी. Presently, we have a mine, and that mine is at Jaduguda. We don't get much uranium from there, but recently we have found some in Karnataka and Andhra area. कुछ हमें कुछ mines मिली हैं at Gogi, at Tamallapalli, and at Lamapur. Work is going on over there, and yet we have not started, you can say, getting from there, but some work is going on. So friend, this is one wonderful application of the, you can say, atomic energy, which can help us to arrest the climate change as well as to fulfill our, you can say, electricity need of India in the developed India. And how the government of India is going on, that I have told you. कि budget में इसका क्या provision है, that I have told you. Then there is a very wonderful application of this radioisotope that is in the health sector. Health में बड़ी कमाल की इसकी application है. Friends, health में, in health sector there are 3 major activities. One of them is diagnostic, बीमारियों को diagnose करना. Second one is the therapy. Therapy means treatment करना. And third one is the sterilization. Do you know? The syringes, the needle, the catheters, ये अलग अलग तरह के पाइप वाइप वगैरह जो डॉक्टर लोग यूज करते हैं during treatment, these are very cheap in India. And that is because in India, atomic energy or nuclear radiations are used for sterilization. Let me see them one by one. So friends, you know X-rays. सबने देखा होगा. Can anybody tell me X-rays will come under which category? Diagnostic, therapy or sterilization? फ्रेंड्स, जो एक्सरे हम कराते हैं वो किस कैटेगरी में आएगा तीनों एप्लीकेशन में से?
Diagnosis.
Yes, this will be used in the to diagnose the problems in the body. And second, if I come to the nuclear medicines, friends, nowadays lot of work is going on the radiopharmaceuticals. And even in chemotherapy and radiotherapy, you all know the radiations from the cobalt-60 are already used. But now in nuclear medicine, the main workhorse, remember this thing, the main element which we are using or researchers are using, that is technetium-99M. M stand for metastable. Technetium-99 is the radioisotope which is used in the nuclear medicine. The reason of using this technetium-99 is that its half-life is just 6 hours. So within 60 hours, 60 घंटे में, this will be completely washed out from the body. So body will not be having that much effect of this technetium. If we use any other radionuclide whose half-life is longer, certainly that will stay for a longer period in the body and maybe having the more harmful effects. If you are interested in nuclear medicine or technetium-99M, please read about this. Lot of literature is available on the internet. Yes. Friend, this is another technology that is called as gamma knife. Basically, gamma knife is a technology that has recently been developed, and this is used to treat the brain tumor particularly. If you see this lower photograph, इसमें एक आदमी दिखाया है that is wearing this helmet. Yeah, let me enlarge this picture. Can you see the enlarged picture? मैंने थोड़ा बड़ा किया, दिख रहा है क्या ये पिक्चर?
Yes, sir.
होता क्या है, the patient is taken into this machine, ये जो ऊपर मशीन दिख रहा है, and then this and the head of that patient is put in this helmet, and you see there are number of holes, and through these holes very weak gamma radiations are targeted to that part of the brain that is having tumor. इसके थ्रू रेडिएशंस थोड़ी कम एनर्जी की उस पर्टिकुलर पॉइंट पे जाती हैं जहां पे आदमी को कैंसर है. बट व्हेन दीज रेडिएशंस कन्वर्ज एट दैट टाइम एट वन पॉइंट, एक जगह पे जाके जब ये सारी मिल जाती हैं, दैट टाइम दे प्रोड्यूस a very big effect, means they have lot of energy over there due to the convergence, or then they kill the tissue that is having tumor, and no other tissue surround that is affected. So, and this technology has come in India also. I will suggest you friends, please read about this gamma knife technology, that what is this technology. Yes, so this is what I was talking about, sterilization, that why these things are cheaper in India. In India, there is one project, the name of that project is ISOMED project. ये जो मैंने लिखा है, the picture has been taken from the website of ISOMED project. ये जो है ISOMED, actually we have 2 plants, one in Bangalore and one in Delhi. जितने भी हमारे ये मैन्युफैक्चरर लोग हैं जो इंजेक्शन सिरिंजेस वगैरह बनाते हैं, इस तरह का सामान प्लास्टिक का, they pack their material into the boxes and boxes are sent to these plants, and these plants, they pass their material through this machine, and this machine is having a radiation source, gamma radiation source, cobalt 60, and that kill all kind of pathogens which may be present with that material, and material gets sterilized, and because of this this is cheaper. And now I think government was thinking to give this to the private players also, this technology, but yet it has not been given to any private players. Similarly, I want to tell you that in India there is only one agency that can have the nuclear power plant. अभी तक सिर्फ एक ही कंपनी है जो न्यूक्लियर पावर प्लांट लगा सकती है इंडिया में, दैट इज NPCIL, and NPCIL is a government agency. Till date there is no private player, but from this budget I think government may ask some private players to have the nuclear power plants in India. Okay friends, ये एक बड़ा important application हो सकता है रेडिएशन का. आपने कई बार सुना होगा कि when our farmers harvest the potato or onion etc., जब ये इसको फसल अपना वो उगाते हैं, that time the prices are very low, so low that they even don't get the cost of transportation from their place to the mandi, to the market, तो वो उसको उधर ही फेंक देते हैं. On the other hand, कई बार situation ऐसा होता है कि the prices are very high, we people like you and me consumer get it at a very high price. अच्छा, फिर इसमें रीजन क्या है? इंडिया इज नॉट हैविंग दैट मच ऑफ द स्टोरेज फैसिलिटी, हमारे पास नहीं है. और इन द absence of storage facility, what happen, these materials start germinating, and once these start germinating, these are of no use. So if somehow we stop their germination, then their shelf life will be increased, and once their shelf life is increased, we can have these for a longer period with us without spoiling. So here nuclear can play very important role. The gamma radiations can be used to kill the vigor of these things. अगर इनका हम germination का power kill कर देंगे making the use of gamma radiation, तो ये germinate नहीं करेंगे and these will remain here for very longer period. उसके दो advantage होंगे. Number one, farmers will get the good price, as well as consumer will never have their shortage, and they don't have to pay the much higher price in the situation of shortage. Friends, similarly, radiations can be used to produce the new varieties of the crops. There are different universities as well as agricultural division of the Bhabha Atomic Research Center. They have produced a number of crop varieties making the use of nuclear radiations. Actually, how do we develop the new varieties? There are 2-3 ways to produce the new varieties. One of them is the selection process. In selection process is a very old process. In the selection process, what we do, these people, those are developing these varieties and that all, they go to the agricultural field and they look on all plants, and if they find some abnormal plant, कई बार होता है ना खेत में एक आधा plant अलग होता है औरों से, they select that plant, and then they take the seeds of that plant and then they multiply it, and then they develop a variety. But this process takes very, you can say, large number of years. 8, 10, 20 साल लग जाते हैं इसमें by selection process. Other way is by mutation, that you take some seed and you do some kind of mutation, and the mutation can be done by the physical factors, this can be done by the chemical factors, as well as this can be done making the use of radiations also. So the varieties which have been developed which have mutated varieties that have been developed, making the use of radiation. These varieties are high yielding varieties. Some of them are having better nutritional quality, and some of them are disease resistant, some of them are heat resistant, some of them are you can say drought resistant. And these varieties again will help us when we will come for the when we will talk about this mitigation and adaptation of the climate change. Abhi time nahi hai, so I will not be discussing much into that. Friends, this is another very important use of the nuclear radiations. These can be used to control the insects. How? You know that there are many insects which are useful to us, and there are many insects which are harmful to us. But in the whole environment, every insect is having its role. We cannot completely eliminate all the insects. But there, for example, let us take the mosquitoes. We know that mosquitoes cause a number of problems, whether malaria, dengue, etc., Zika, Vika. So many different kind of problems are caused by these, but we cannot completely eliminate them. We want to keep their population at a level that is not harmful to us. So, उस case में nuclear can play an important role, and the technology which is used there, that is called as SIT technology, that is sterile insect technique. This technique is used. In this technique, actually, what is done? Production of the male insects is done at mass level. बहुत सारा mass level पे male insect को हम produce करते हैं, and then radiation dose is given to these male insect, and they become sterile. And once they are sterile, they are not able to these sterile insects are then released through aeroplanes, etc., in that environment. उसको वहां हम इसको release कर देते हैं. These insects now will mate with the females which are there in the environment, and the females will produce the eggs. But friends, the eggs will not be means the eggs which are, you can say, given by these female, they are infertile egg, they are not fertile egg, and no new insects will come out of these eggs. So that way the population of the insects will be cut under control. I will give you example of the Brazil. There was an outbreak of Zika virus in the Brazil, and then to control that mosquito which is responsible for the spreading of Zika virus was controlled, making the use of this SIT technology. If you are interested, you can read more about this. Okay, friends, if I come to this wastewater treatment. In wastewater treatment, you know, there is primary treatment, secondary treatment, and tertiary treatment. And during these all the treatments, the sludge is produced, solid sludge is produced. Presently, we are not doing anything to this sludge. Kuch karte nahi hai, remains scattered here and there. But if I look on this sludge with the eye of a chemist, then I'll find this is having a very good amount of carbon, very good amount of nitrogen, very good amount of phosphorus. And due to the presence of carbon, nitrogen, and phosphorus, this can be a very good quality manure. बड़ा अच्छा manure ये हमारा बन सकता है. But we cannot use this sludge as manure in raw form because it is containing a number of pathogens. बहुत सारी इसमें बीमारियां होती हैं भाई. उसके pathogens होते हैं, cannot be used as such. तो इसका एक तरीका निकाला गया है. बड़ौदा में एक प्लांट लगाया गया है, one plant, and the name of that plant is Shri, SHRI. Please note down the name, Shri. Full form of Shri is Sludge Hygienization Research Irradiator. Inside there is a machine. That machine is having a radiation source. So the sludge is taken into some containers and passed through that machine. And the radiations are passed through that sludge, and because of the radiation and the energy present in the radiations, the microbes, the pathogens which are present in them, they get killed or get destroyed. So when it comes out of this plant, this is a treated sludge, and then it can be used in our agricultural field as a manure. So presently we have one plant at Baroda in India. Now I think soon we may be having one more plant, that is in Indore. Indore municipality was interested to have this plant. Friends, similarly, nuclear can be used for the water desalination. Basically, nuclear can be used in two ways when I am talking for the water treatment, because we need water for the drinking purposes also, na? So I'm talking about that. So number one, with the help of nuclear, we can produce the electricity, and that electricity can be used to run the plant. And that electricity can be used to heat the water and to get the, you can say, treated water or desalinated water. Friends, the very first nuclear desalination plant was established in Kazakhstan, and you will be surprised to know we have one water desalination plant based on nuclear in India, that is in Kalpakkam. कालपक्कम के बारे में आप जरूर पढ़िएगा. वी हैव वन डिसैलिनेशन प्लांट, और वो एवरी डे 1800 मीटर क्यूब ऑफ ट्रीटेड desalinated water is produced from that plant. So what is the advantage of this? Number one, we will get water for drinking purposes, which is one of the basic requirement. Secondly, this will help us to arrest the climate change, because if we will use the coal to produce the electricity that is used to heat the water, again carbon dioxide will go to the environment. But if we will use this SMR kind of thing, small modular reactor, etc., for the water treatment, no carbon dioxide production will be there, no release of carbon dioxide in the environment, and there will be certainly some contribution in arresting the climate change, and as well as this can play an important role in achieving the sustainable development goals. Friends, nuclear can be used to reveal the truth. You know, in the market, a lot of fake artifacts, fake mummies, etc. So many paintings are available in the market. Whether these are original, whether these are fake, this all can be detected with the help of radiocarbon dating. So I will not be talking much here. So you can read about this. Okay, friends, let me come to the last part of this presentation. As I told you during my presentation, one nuclear power plant is coming up in India, Haryana, that is in Gorakhpur village. Earlier this was in Hisar and Fatehpur. Whenever, anywhere, any nuclear power plant is started, जब भी दुनिया में कहीं भी होता है, the very first studies which are done for that nuclear power plant, they are called as environmental studies. सबसे पहले environment की study होती है उस area की, and these are the 4 projects which are taken up for in that area. ये 4 प्रोजेक्ट किए जाते हैं. द वेरी फर्स्ट प्रोजेक्ट इज ऑन द डेमोग्राफिक सर्विलेंस. लोगों के बारे में, उनकी हेल्थ के बारे में, एपिडेमियोलॉजी के बारे में पता लगाया जाता है. एंड दीज ऑल स्टडीज आर डन विद इन 30 किलोमीटर रेडियस. ये याद रखिएगा, 30 किलोमीटर के रेडियस में होती है. पहली होती है डेमोग्राफिक स्टडी. सेकेंड स्टडी इज डन ऑन द वाटर क्वालिटी इन दैट एरिया, इन ऑल द सोर्सेज एंड द वाटर क्वालिटी इन दैट एरिया विद इन 30 किलोमीटर रेडियस. तीसरी स्टडी होती है व्हाट इज द बेसलाइन रेडियो एक्टिविटी इन डिफरेंट मैट्रिसेस. मैट्रिसेस मींस इन सॉइल, इन वाटर, इन एयर, आज क्या है रेडियो एक्टिविटी. एंड देन फोर्थ स्टडी इज द ट्रांसफर फैक्टर ऑफ स्टेबल एंड अनस्टेबल एलिमेंट्स within 30 kilometer radius. Here transfer factor means bioaccumulation, that how much, when I say stable, I mean I'm talking heavy metals here. Unstable, I mean I'm talking radionuclide here. Okay, how much bioaccumulation from soil is taking into the crops. This is called as transfer factor with respect to the unstable elements. So friends, you know why these studies are carried out. These demographic studies are carried out. The reason for those studies is, suppose plant has come into existence, plant is operating, and 30 years down the line, 30 साल के बाद कोई आदमी कहता है कि जी हमारे यहाँ तो कैंसर रेट बढ़ गया, हमारे यहाँ तो ये कम हो गया, हमारे यहाँ तो जो है स्टिल बेबीज का बर्थ होता है. लाइक दैट पीपल कैन से एनी काइंड ऑफ थिंग. सो फॉर दैट सम बेसलाइन डाटा इज रिक्वायर्ड. सो दिस प्रोजेक्ट will act as baseline for that kind of allegation. Similarly, somebody say that water quality has changed, air quality has changed. The data which has been generated now, that will act as a baseline data for that situation. Same is with radioactivity and same is with respect to transfer factor. So friends, so the very first thing which we did for this project, we got prepared a map of 30 kilometer radius of this. We were provided the latitude and longitude of the site by NPCIL, और फिर हमने ये मैप इसका तैयार किया. And we found there are 252 villages within 32 किलोमीटर रेडियस, और 2-3 इसमें सिटी आते हैं. One is Hisar and second one is Fatiyabad and Barwala. These are small towns. Okay, friends, to decide our sampling stations, किस जगह पे हम ये चारों प्रोजेक्ट की स्टडी करेंगे, we needed the windrows diagram. The data was not available to us for that particular site because that is in some village, in some agricultural fields. So we took the data of the air of the nearest place, that is Hisar, which was available to us from the meteorology department, and based upon that we prepared this windrows diagram. And from this windrows diagram we found that most of the time in that area wind is blowing from north to the south, and about 70% time the air is calm, and most of the time air is very slow. Why this information is important for us? It means, suppose in any situation there is some kind of leakage, there is some kind of spillage from the plant, that will move in the south direction, because wind is blowing mainly from the south, and this will not blow, this will not move very fast as the air is very calm. So we were interested to have our 50% sampling station in the downwind direction, 25% in the upwind direction, 10-12% on the right hand side, and 10-12% on the left hand side. Like this we distributed our, so these villages were our sampling villages for those 4 projects. Similarly, there is a canal, and the water of that canal will be used for the this plant. Actually this about 330 cubic 330 cubic water will be taken from this canal, and we sampled water of this canal and prepared a report that this is the quality of the water. So if anybody do some allegation regarding the quality of the water in the coming years, this report will act as the baseline report for this you can say canal. And friends, for this plant 1503 acres of land has been acquired, and this is the map. This straight line is indicating that canal which I am just talking now. And friends, this is the total number of trees which is presently present at this location. And NPCIL has promised, and they are working also, that whatever tree will cut, jitne hum tree katenge uske 10 times trees we will plant at different locations in the vicinity of our plant. Friends, then we were interested to know the crop patterns of that area. So we did this remote sensing. We took the help of remote sensing people for Rabi season as well as Kharif season, and we found that there are 2 major crops in the Kharif season. One is rice and other one is cotton. Similarly, in the Rabi season, we found there are, I think, 1 major crop only, that is wheat, depicted by green color. And the second major crop is the this mustard, that is this yellow color in the map is representing that mustard, and these brown color locations are the known agricultural locations where the people are living, and that all. So friends, we sampled all the water sources, whether this was a hand pump, tube well, canal, wells, pond, johod, sabka pani ikatha kiya from these locations, and this was analyzed for general water quality parameters as are given by the BIS, as well as for the radioactive parameters like gross alpha, gross beta, uranium, tritium, heavy metal, etc. इनके लिए हमने इनको analyze किया. I will not be discussing the results. So similarly, we monitor the air quality, and in the air we monitor the normal parameter, and along with that gross alpha, gross beta were also monitored. Then ये हमने अलग-अलग खेतों, all the seasons we collected different crop samples. Crop के साथ-साथ हमने उसका मिट्टी का भी sample लिया, and then these samples were analyzed for potassium 40, uranium 232, 238, thorium 232, radium 226, cesium 137, strontium 19, सबके लिए इसका हमने analysis किया. Similarly, same was in the transfer factor project. Friends, then we did one more project. We were interested to know what are the radiation level inside the houses and outside the houses. जो मैंने शुरू में एक बताया था कि we have some radiation in our houses. तो ये हमने किया, और इसके लिए ये जो डिवाइस बच्चा लगा रहा है, now his faculty somewhere, this device which is in his hand, this is called as TLD, thermoluminescence detector. इसको घर के अंदर लगाया, घर के बाहर लगाया, and then we calculated the dose which a person is getting from inside the house as well as outside the house, और ultimately total dose हमने इससे उसका निकाला। एक साल में इसको 4 बार करते हैं, 3-3 महीने पे, like that we did this, and so this all data we have submitted to the Government of India, and Government of India has submitted this data to the IAEA, which is the basic requirement. Now, similar study we have done for the this Narora nuclear power station, that is in Uttar Pradesh in Bulandshahr district. Actually, this power station came into existence in 1992 में ये plant लगा था, and that time there was not the requirement to have these studies. उस time होती नहीं थी जरूरत, तो Government of India ने ये हमसे बाद में सारी study इस plant का करवाया, and we did this all. Friends, then this is also very interesting. There was one question in the Parliament of India that what is the level of uranium in the drinking water of India, and the reply of the minister was that we have data only for few locations, and those studies are done by the Atomic Mineral Department of the Government of India, but we don't have the data of uranium in the drinking water. So in response to this question, a national level project was started, that is called as National Uranium Project, NUP was started, and we were part of this project, and we have monitored the uranium in the water of Haryana as well as Punjab. We made 8 groups, क्योंकि एक आदमी तो नहीं कर सकता इतना काम, तो हमने अलग अलग लोगों ने मिलके इस काम को किया, and in total I think country में 60 या 70 लोग थे, those have done this. If you are interested, you search on the internet, you will find that who got the project, this project in your area, और क्या आपके रिजल्ट रहे वो कहीं ना कहीं आपको इंटरनेट पे आपके बारे में जरूर मिलेगा, कि कितना आपके पानी में ड्रिंकिंग वाटर में यूरेनियम है, that you will get. So here I have shown drinking water map of the Hisar district, and these dots are indicating that uranium is within permissible limits. Some points are not visible. Let me show you another graph. Yes, this is of Fatehabad district. This is also district of Haryana. Here the green dots are showing that that this is within permissible limit, and these blue dots are showing that these are some of the location where uranium is more than the permissible limit at this location in the drinking water. I think more studies are required that why uranium is higher in the drinking water at this location. So from this grant, friends, we set some of the laboratories. In the last, I would like to show you some of the pictures of the labs which we set. We were given a total grant of about 5 crore rupees for this project. So this was our wet lab where we did all kind of chemical works, and this was our testing lab. Yes, these are, yes, this instrument is called as HPGE, high purity germanium detector. So this was the main instrument in which we did the radioactivity counting in the solid materials. Liquid किसी में भी कर सकते हैं, पर हमने उसमें ही किया था. Then this is gross alpha counting. ये ऊपर वाला जो है, this is beta counting system. नीचे वाला, ये side वाला जो है, this is low beta counting system. And these are my gamma counting systems. And this is that HPG. ये beta और gamma दोनों को count करता है. We also had a liquid scintillation counter, have this liquid scintillation counter, and in this we mainly working on the monitoring of the tritium in the air. Air में tritium कितना है. Then this equipment called as laser fluorimeter, this is used for the estimation of uranium in the water. And then AAS. Then we had ion chromatograph and voltammetry also for the speciation of different heavy metals. And many other small equipments were purchased under this project, which are presently used by people for their research work, etc. So friends, thank you very much for this. I'm closing this presentation. And if you have questions, you can put to me. I will try to answer the questions. If you have any questions, please, you can ask any kind of doubt you have in your mind. Sir, as far as present PPT is concerned, PPT is already given to the organizers, and they can share with you. So if you have any question, please put to me. I would love to answer the questions. Any question? Raut, when there is no question, this is having two meanings. Either everything is clear or nothing is clear.
Sir, I have a question.
Please.
Sir, the session was so interactive and well explained that perhaps the participants have no doubts, and like whatever, when we'll share the PPT, whatever doubts will come up, they'll connect with you through your mail or something.
Sure. Yes, Ram.
Regarding the windrows, preparation of windrows diagram, generally we measure the wind direction from north-east direction. You mentioned from south, I think.
Pardon?
From the south direction.
No. Wind is coming from north to south. I'm very clear about this.
But in textbooks, it is written northeast.
Where it is written? Should I share my PPT?
Gilbert.
You know how the windrows is prepared?
A bit, sir.
A bit, na. So read about windrows. It is having 16 directions.
Yes, sir. Yes, sir.
16.
Yes.
So if you will see, this is the graph was like this. That was representing that line of the north. So wind is going completely from north. I am no doubt about it. That is north to south. Okay, आप देखिएगा the presentation which I have shared with you that clearly shows wind is from north to south in that area.
Yes, sir. Yes, sir. Thank you, sir. But northeast for Indian context, it is written.
It may be northeast in Indian context, but I told you for that particular location, 70% times this is north to south. There may be in any context, but for that location, this is north to south. Okay. So I think if there is no question, then we can close the session. So over to the organizers, please.
Okay, sir, on behalf of our participants, it is my privilege to express my deep sense of gratitude to you for your invaluable talk on atom for peace. Sir, your insights into the need for electricity, the global nuclear scenario, the role of power plant stations in India are truly inspiring. Your explanations on the application of radioisotopes, urban and rural wastes, recycling, water treatment through desalination, application in agriculture sector, etc., highlighted the critical opportunity in these fields. Sir, we are inspired by your vision for a sustainable future. Thank you, sir, for sharing your expertise and igniting our passion for innovation in energy and environmental solutions.
So thank you all and have a nice evening and enjoy your evening. So I'm leaving now. Thank you very much. Thank you.
And now the session will be next session will be started, sir, at 5 p.m.
Sure. And, soon. Right now, I am just looking, Ma'am and Dr. Vrinda joined.
Yes,
we should continue.
She is in the meeting. She has joined.
Okay.
We should continue the session.
Yes, sir.
We will continue with the session.
Okay. So I am now inviting Dr. Vrinda. So I am just introducing her. And Dr. Vrinda is currently working as an associate professor in the Department of Electronics and Communication Engineering at NIT, National Institute of Technology, Kurukshetra. She has worked as an engineering teacher for more than 30 years. She has authored 85 publications in reputed journals, edited books, and proceedings of national and international conferences. Also, he hosted, he visited in abroad also. She has delivered more than 20 keynotes or expert lectures in various national as well as international conferences, and also in faculty development programs. She is also a researcher in the field of communication networks and Internet of Things. Now I am welcoming Madam to continue this session on behalf of our participants.
Thank you, sir, for your warm welcome and introduction.
Thank you, ma'am.
Should I start my presentation?
Sure, ma'am.
Sir, is it visible?
Yes, ma'am. It is
Okay,
visible.
thank you. So here I am to talk on the topic technological innovations for sustainable development. This would be the outline of my presentation. I would be introducing sustainable development, what it is, what are the sustainable development goals known as SDGs. We'll be learning about them. What are the technological innovations towards achieving sustainable development? Then the role of AI, artificial intelligence, Internet of Things, and biotechnology in contributing towards sustainable development. Further into that, we have certain technologies, renewable energy technology, innovations, circular economy, waste management technology, sustainable transportation, green infrastructure for sustainable development. And a major role would be of the digital innovation. So how they are aiding towards sustainable development, what are their impacts, and those will be studying with the help of 4 case studies. And then I'll be concluding my presentation. So what is a sustainable development? It's an approach to social, economic, and environmental planning. It seeks to balance the social and economic needs of the present and future human generations with the preservation of and prevention of undue damage to the natural environment. Its health should be preserved. The natural environment should be preserved. It recognizes that economic growth and social progress must be achieved in ways that do not exhaust or irreparably harm our planet's resources or ecosystem. So it's an approach that meets the needs of the present without compromising the ability of future generations to meet their own needs. It involves integrating economic development, social inclusion, environmental protection in a holistic manner. So if we adopt certain sustainable practices like reducing pollution, waste conserving, biodiversity conservation, we can improve our quality of life, promote economic stability, safeguard the natural systems upon which our life depends. Sustainable development includes 3 pillars that contribute to a sustainable society, as you can see in this diagram. First one is the social equity. What it refers to? It refers to the fair and just distribution of resources, opportunities, political power within a society. It means that everyone has a chance to get ahead and participate in economic, political, and social life. Second pillar is economic viability. It refers to the ability of a society to produce goods and services to meet the needs of its population in a way that can continue into the future. It has various goals like long-term focus, sustainable economies prioritize practices that benefit the future, not just the short-term gain. Resource efficiency, it should be resource efficient so that we can minimize waste, we can promote recyclability. It should introduce innovation, fairness. Fairness means considering all sections of the society, not just the wealthy. Full cost accounting. So these are certain goals that are required for achieving sustainable development. Environmental protection is another pillar. So third requirement for achieving sustainable development. So it refers to the act of protecting the natural environment from degradation, which is caused by the human activity. So to reduce it, it includes things like reducing pollution, conserving resources, preserving biodiversity. In the diagram shown here, the approach to sustainability, the sustainable word is written in the center. So it represents that for a true sustainable society, it must consider all the 3 pillars together: social equity, economic viability, and environmental protection. It is not enough just to focus on one aspect. It should include all the three aspects. Sustainable Development Goals. So second topic means part of our presentation, that what is the agenda? It has been announced by United Nations and it has been adopted by all the members in 2015. It was created by 17 World Sustainable Development Goals. So the aim was to achieve peace and prosperity for people and the planet while tackling climate change and working to preserve oceans and forests. So these SDGs, the Sustainable Development Goals, they highlight the connections between the environmental, social, and economic aspects. These are the 17 Sustainable Development Goals announced by the United Nations. We have each one with a number. So SDG 1 is no poverty, SDG 2 is zero hunger, good health and well-being, quality education, gender equality. So globally, we have to achieve all these: clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduce inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice, and strong institutions, and partnerships for the goals. So, United Nations has provided a report in 2024. And for each goal, what is the achievement? And how we can achieve, what is the trend, how we can achieve by 2030. So that is being shown here. The first goal was no poverty. It aims to end poverty in all its forms for everyone. So it is saying that by 2030, still people will be living in extreme poverty if the current trend persists. So we are still very far behind it. Goal 2 was zero hunger. So it is showing that under age of 5, still one of the child will be affected by malnutrition. Sorry. Goal 3 is good health and well-being. So it aims to achieve health for all. So still it is showing that we have undergone COVID-19 pandemic and it has reduced the life expectancy. So decline is there in achieving that goal. Quality education, it is showing that the report 2024 shows that in this decade, we have achieved to some extent upper secondary level completion, primary level completion, it has increased. So there's a trend positive in this direction. Goal 5 was gender equality. So there is inequality still. Women are still spending more time and not earning that much. Clean water and sanitation. So at the current speed, if we go, people will still live without safe and drinking water. Goal 7 for providing electricity. So it is again a number of people would be so much which will be having devoid of electricity. I would like to take a pause. Am I audible?
Yes, ma'am. Yes, ma'am. You are audible.
Okay, I'll again start. So we have number of goals as I was illustrating. We have,
Sir, madam, please turn on your video, please.
pardon?
Video, your video, please.
Okay, I have to
PPT is visible. Slide is visible. Yes, ma'am.
So we have number of goals as I was announcing. So that is given by United Nations. Number 9 was carbon dioxide emissions. It is again a trend is there that it is rising. We have to reduce that to achieve sustainable development. Then most of the countries are still facing gap with the means economically there is a gap, so that we need to reduce inequality in amount of the wealth. Then number 11 was sustainable cities. So there's again a decline in that. Large population and many of the cities still live in slum areas. So we need to reduce that. Then we have to have responsible consumption, production. Globally, we are seeing that waste of food is there and hunger is there. So hundreds of millions still face hunger. So how we'll achieve that by 2030? What will be the achievement that we have to look into? Climate action, very important goal. We are all seeing that the temperatures are rising. Globally, it is rising to 1.5 degrees centigrade around. It has risen. And the decade has been warmest. 2023 has on record the highest temperature. So we need to reduce pollution and work towards that. Marine life is also being affected. So sustainability, to achieve that, we need to look into all these parameters. Deforestation is one of the cause. For life on land, it is affecting our climate and etc. Other parameters are being affected by deforestation. We need to reduce that. Casualties are there. So in military organizations, as we are already ongoing war at Ukraine, and we are seeing that it has risen. And partnership for goals. We need to accelerate the progress, and we need to collaborate and have a collaboration with other organizations. It could be private sector, government organizations. We need to work together to achieve sustainable development goals. And the last diagram here is showing that how we'll deliver that promise, what we want to achieve. The agenda is of 2030 to achieve that. Still, we are only 17% of the sustainable development targets are on track. The rest we are failing to achieve if we go by this trend. So it's a very serious issue. We need to look into all these parameters. If this is the report of 2023, for each goal again, which I had already defined. So how we can achieve, what is the trend, and how much change in trend was there between 20 and 23, and what progress has been achieved. So we can see that hardly any progress or limited progress, only deterioration is even there and no change is there in many of the parameters in achieving sustainable development. So this is the trend showing in 2023, the report is giving. So again, you are seeing no means close to target, no green color in any of the goals. Here you are seeing some place green color, that is, we have access to mobile network that has enhanced. So that is one area where we are achieving. So digital technologies like mobile communication is being implemented and utilized by many. So again, this is all limited in progress. And here you are seeing green color that is showing that internet use is there. So large population is still means having access to the internet now. So that is substantial progress and it is on track. What are the major pointers for achieving global sustainable development? So it is not independent of the nations and countries, means each uniquely they are progressing. And only we are seeing growth in the digital space, that is increase of the internet use and the mobile use. And deterioration we have seen in all other sectors like food security, sustainable economy, affordable housing, marine life, aquatic life, land life, climate action. So all these areas we are very far behind. Factors which are preventing nations from reaching SDGs. These are the major factors, though I have not means details report, but on my study I have obtained that these are certain factors which are preventing nations from reaching these. Lack of adequate funding is there, so it requires funding. The government should provide funds to achieve those goals. Inequalities there and social disparity exists. Climate change is occurring. So it's environmental degradation, pollution, conservation of biodiversity is not being obtained. So all these are contributing towards not achieving sustainable development. Weak governance, institutional capacity, lack of data. So data plan is also not there. It has to be more enhanced. Global economic uncertainty is there. Technological and digital divide is existing. Health sector also we are failing, and in partnership and collaboration also we are failing. So these are certain factors which are preventing many of the nations from reaching sustainable development goals, which are coming to our rescue, which are aiding us, which are helping us are the two, as I have already highlighted. It is increased access to mobile network and increased internet use. These are the two technologies, mobile communication technology and internet technology, that has been enhanced and progress is there. And with the help of those, we can contribute towards sustainable development. So in my next part of the presentation, it will be highlighted at how we can have a sustainable development by having digital technologies usage, like AI, is one of them. Nowadays, it's the buzzword, and IoT, Internet of Things, blockchain technology. So using all these three technologies, how we can promote sustainable development. Technological innovations. The topic of my presentation was technological innovations for sustainable development. So what is technological development? It refers to the development and application of new technologies. Either you develop new technologies or apply new technologies or improve the existing ones and create better processes, better solutions, better products or better systems. It has addressing many of the challenges. It can enhance efficiency, it can improve quality and more opportunities for work at the industrial level and the society level can be obtained. Types of technological innovations are there. We'll be seeing each one of them. Types means it could be in what all forms. So first one was product innovation. So we can either innovate certain products. So new product could be developed. Like we have already gone into many of the devices like smartphones, enhancement has been there in the features. Electric vehicles now being used, wearable devices now being used. So these are examples towards this technological innovation in terms of product innovation. Process innovation could be another way of having technological innovation in the form of process improvement, either in the production level or in the operational level. So we have the example for that is automation in manufacturing using robotics, 3D printing. It could be in the form of disruptive innovation, so which is revolutionary technologies that are disrupting the existing market. So it could replace our traditional TV, like we are now using streaming services. So it is an example of disruptive innovation. Incremental innovation, another form of technological innovation could be there. So we could have incremental change, gradual improvements in the existing technologies. So adding more features in the smartphones, like cameras being used in the mobile phones, and better features could be enhanced in that. Sustaining innovations could be there. That is focusing on improving the existing products, services, technologies to meet the needs of the current customers. It could be, the example, it could include many medical devices we have, like blood glucose monitors. So we can improve upon that. With more accuracy, we can measure. So like that. Frugal innovation, sorry. Re-innovation could be there. So taking existing product or idea and adapting for a new market, could be, or audience or application. So re-innovating the innovation. So that could be like, now we have so many features in smartphones, like chatting feature, so video calling on that, or traditional bikes have been replaced by e-bikes. Digital innovation is also playing its role. So it means, again, to create either new product or processes or improve upon the existing ones. So this is an example showing that how digital innovation has taken place in the wristwatch. Earlier version of the wristwatch was just showing the date and the time. Then came a revolution in that showed many other features, like alarming feature was there, illuminated display was there, digital display was there. Then we had another version of the wristwatch now incorporating other things like capturing our steps count, heart rate, many of our biological parameters, we can check on that. And it is connected to the internet now, running different apps. It can even use for chatting. So how the innovation has taken place in the wristwatch. Key digital innovations could be in these areas, some of them like artificial intelligence, I've said, smart home technology using Internet of Things. All the devices could be controlled and connected to the internet. We have seen e-commerce, that is, we are now doing shopping on virtual platform, online shopping is there, and how it has eased our shopping, and we need not handle cash now. With digital payment systems, it is allowing us to have more secured transaction compared to cash, and convenient transactions, and more at ease we are now. In terms of healthcare sector also, digital innovation has taken place. Now we are going towards telemonitoring, and digital tools are there which could be used for medical sector. Collaborative platforms like online platforms are there. We can do video conferencing, etc. among the organizations. Any organization for meeting, they can now virtually meet, and it is easing our and means not using our resources in terms of time, in terms of money. We can reduce that. Combustion, etc. could be reduced. How AI is playing its role in sustainable development. So AI is playing a very crucial role. It is used in optimizing resources. It facilitates that. It improves efficiency. It reduces waste. We are seeing many of the innovations in using AI, like smart energy management could be used in power grids we are using. It can predict energy demand. It can integrate renewable energy sources efficiently. So with the AI powered algorithms, AI is complex algorithms that can be utilized. Precision agriculture sector also, AI driven analytics are there. It is helping us in soil monitoring, pest detection, yield prediction, reducing water. So water usage, water is again a very important resource, we know. So we need to reduce wastage of water and pesticide usage. Climate change, how it can be mitigated with the AI help. AI models can be used to predict climate patterns. It could analyze environmental data, help in that. It could assist in disaster management. So AI is playing a very important role towards achievement of sustainable development. In smart cities, AI is being used in urban planning. It is being used for optimizing traffic flow, for enhancing waste management systems. Another important digital technology is Internet of Things. It is also aiding towards sustainability. It means that all the things, all the devices would be interconnected and would be connected through the internet. So it is enabling us to have real-time monitoring now and improving our resource management. So various innovations in that can also be there, like smart water management could be used with the help of sensors. IoT involves basically sensors, and sensors are means devices which can sense any parameter, any physiological parameter from the environment. So we have many types of sensors for measuring any of the physical parameters. We have humidity sensor, we have acceleration sensor. For various purposes, sensors are available. So being interconnected through Internet of Things. So it can be used for water management, like for detection of leak detection, for water quality monitoring, for irrigation precision, etc. Energy efficiency in buildings, for energy resource. Energy is again a very precious commodity. We need to efficiently utilize our energy consumption. So we can use sensors in our lights, in heating, lighting, and ventilation systems, cooling systems, etc. We can have industrial automation with the help of IoT. So industrial IoT is another branch now running. So automation, for provision of automation, IoT is helping towards that. It is enhancing predictive maintenance, reducing downtime, energy wastage in manufacturing. So in the plants, in the factories, IoT could be utilized. Sustainable transportation. So with the help of IoT, we can have more traffic management, more better. We are seeing congestion in the traffic. We can monitor our vehicles and also reduce emissions. So IoT was another digital technology that was aiding towards sustainability. Biotechnology is another major key player here. So key innovations in that are biofuels, biodegradable materials, advances in bioengineering. We can have alternatives to fossil fuels. We can use genetically modified crops. They can improve food security by increasing yield. So we can use biotechnology for that. Waste treatment, we can use biotechnology. Personalized medicine also can be there. It can enhance healthcare sector and make it more effective and sustainable. We can achieve sustainability by collaborating on these technologies also. So if we have a combination of AI, IoT, and biotech together, we can have smart farming. AI would be analyzing the data which is being collected by IoT sensors and for precision agriculture, and biotech could be used to improve crop resilience. We have another technology that is circular economy. I'll be dealing with that in more detail later on. It is using AI and IoT together. So AI-driven analytics could be used and IoT could be used together, and it could track, enable efficient recycling and reduce waste. In terms of healthcare innovation also, we can have AI and biotech together. It could enhance drug usage, drug administration, etc. In the sector of renewable energy, for achieving sustainability, we need to work towards renewable energy technologies and reduce our fossil fuels usage. So one of the key player in that is solar energy, and how it has helped towards global energy production. We have seen already solar energy is being utilized, and earlier we were already depending on fossil fuels, and that is being depleted. So we need to have usage of other renewable energy sources like sunlight, wind, water, biomass, etc. Certain innovations have taken place in solar energy that is being highlighted here. So we can go for peroxide solar cells, which is means relieving your traditional silicon-based solar cells earlier was being used. Now this is being offering higher efficiency and lower cost. We could go for floating solar farms. So solar panels could be installed on water bodies, and then we need not have land usage over for solar installation, and it can also increase efficiency. And we have a real life example in India, which is one of the world's largest solar park, which is generating 2.2 gigawatts energy. Wind energy could also be utilized in terms of renewable energy sector. So innovation in that is offshore wind farms. So we can have consistent wind speed if we go for offshore wind farms. So they are called wind farms, and that too at offshore level. We can go for vertical axis wind turbines. So in urban areas, it can be utilized. Like we have a real life example for that, London Array at UK. It is providing clean energy to 500,000 homes. For energy storage, we have technology development, and that is achieving towards sustainable development. So we can go for more better solid state batteries for energy storage purpose. We can go for hydrogen fuel cells now. It is an alternative to fossil fuel, and it can be utilized in transportation sector. We have a real life example of that. Honsdale Power Reserve in Australia. It's a Tesla-built battery storage system, and that is storing more renewable energy. Hydropower could be used. We have a tidal and wave energy converters. It is converting the ocean's kinetic energy into electricity. We could go for small scale hydropower also. It could be more cost effective solution for rural areas. Real life example for that is in South Korea. It is one of the largest tidal power station producing 254 megawatts of clean energy. We also have conflicts and challenges, limitations if we go for these renewable energy sources like solar, wind, etc. It would have environmental conflicts, like it could disrupt our local ecosystem. Like example for that is in a case study, it has been found that desert solar farms in California, they have raised concerns about habitat destruction. And endangered species, which are natural habitats, they are being endangered, like desert tortoise. So it has this limitation, challenge also, and conflict also, you can say, in terms of environmental conflict. Marine ecosystem impact is also there. So if we construct offshore wind turbines, it has disrupted local fish population at Denmark. So it's not at certain cost price we have to pay to achieve sustainability. So there's a trade-off again, whether we go for renewable energy or not. But as our fossil fuels are depleting, we need to go for, but to what extent we need to go and which areas we have to work on more, that we have to look into. Technological challenges are there, that it is because of the weather change. We are seeing that inconsistent power generation is there with the use of solar energy or wind energy. Storage cost is there in like limited. It will have a high cost of advanced battery technology, so we need to pay towards that. Social and economic conflicts also arise, as it was seen that community opposition was there in Scotland for protest against wind farms in Scotland due to their visual impact was there. So community opposition also, sometimes local communities, they resist towards going towards sustainable development achievement in terms of renewable energy sources. High initial costs may have to be paid for renewable energy systems to be laid on. Solutions are also there. Conflicts and challenges were there, but then what are the solutions and mitigation strategies? So we could go for coexistence of solar farms with agriculture and conservation or wildlife conservation. Like one example is agrivoltaics in France, that is combining solar panels with farming activities. So both the sectors will be benefited with that. We can go for eco-friendly offshore technologies. We can use noise-reducing techniques during wind turbine installation so that marine life is not affected. Hybrid renewables systems could also be there. So it's again another solution. We can combine solar, wind, and battery storage together to ensure consistent power supply. Like example is there at Bhutan, hydro solar hybrid system. It is optimizing energy generation during different seasons. Towards research and development also, solution could be there. We could go more for more research and R&D and achieve more innovations in terms of renewable energy usage. Social economic strategies could be there, involving local communities could be involved in planning. So before installation, it should be planned with the local community, how much they are being affected. Like in Germany, citizen-owned wind farms are there, where residents are benefiting directly from the renewable energy projects. Government subsidies should also be there. So as the example is in India, we have everywhere installation of rooftop solar panels because government subsidy is there. In terms of tax benefit, it can provide a subsidy, or in installation, it can provide grants. So in summary of the renewable energy technology usage, I can say that it is one of the potential, it has the potential to drive sustainable development by addressing climate change, resource depletion, as fossil fuels are being depleted. So we need to work towards that. It is having this challenge, environmental, technological, social, all these innovative solutions to be produced. And we can go for hybrid approaches, integrated approaches, eco-friendly approaches, community participation, so that those challenges are mitigated. Real life examples have been demonstrated and they can become a helpful aid towards achieving sustainable future. Another sector was circular economy and waste management technology. So this is also contributing towards sustainable development. What a circular economy means, means using recycling, regeneration of resources. So reuse of resources so that we are minimizing our waste, and also it means minimizing environmental impact by using circular economy. So it's an important technology. It is replacing the traditional linear economy of take, make, and dispose, so that we are reducing our wastage. Waste management also requires to be grown up, so we can enable, it is helping in sustainability by enabling efficient resource recovery, reducing conflicts. Advanced recycling technique is there, innovation is there, such as pyrolysis, chemical recycling, which is replacing this plastic and breaking that into for further reuse. So recycling technologies, like circular economy technologies, innovations I'm explaining in this slide. Example company for that is loop industry, that is using depolymerization technology. The impact is that now we are not so much relying on plastic production. Biodegradable alternative could also be there. Example for that is company like Novamont. They have developed bioplastic, which is reducing long-term pollution, and it is decomposing naturally. We have e-waste management technology. So we can achieve metal recovery from electronics, like we could recover rare earth metals like gold, cobalt from electronic waste. So such innovative processes could be used. So using circular economy, again, this technology could be utilized. Example for that is TSAMM, that is using proprietary technology to extract valuable metals like gold, cobalt, nickel, etc. from discarded devices. The impact is that it has reduced the demand for mining. Otherwise, we have to obtain these metals from mining only. Now, by recycling, by circular economy technology, we can obtain these metals. And it is mitigating environmental damage also and thus aiding towards sustainable development. So company is there, Carbon Cure, that is injecting recycled carbon dioxide into concrete during production and thus making it more stronger and reducing carbon emission. So circular technology, how it is helping towards sustainable development, that is being explained in this slide. Brimstone project is there in California that is using recycled materials in road construction. For building infrastructure also, we can have modular construction and towards by using circular economy technology. Biogas production also could be there. We have such processes like anaerobic digestion of organic waste. It is generating methane, which can be used as a fuel. Example for that is Stockholm at Sweden. It is powering its buses with the help of biogas produced from food waste. And the impact is that it is the waste from landfills is being diverted in provision of renewable energy. Usage of IoT and AI could also be there in waste management, already highlighted. The innovation could be, technology could be, like we could use the waste bins. They could be equipped with sensors. When they are filled, then it could be alarmed to the center that the bin is filled and empty that bin. So the transportation could be there and empty that bin at that particular time and scheduling could be done. So it is optimizing our collection schedules, transportation being minimized. Unnecessarily, the bins may not be emptied if they are not full. So alerts could be given, it could be notified to the waste collectors when they are full. So IoT and AI could be used in waste management in this way. One of the example is a Big Belly smart waste system. AI could also be used for sorting. So automated systems could be there which are using AI and robotics to sort recyclables. So for sorting also we can use these technologies. Conflicts are again there in this technology also. Circular economy, if we adopt that, we face certain challenges, certain tech limitations, economic challenges there. Limitations are there that fluctuating prices are there of recycled materials. That makes the market limitation. Technological barriers also come into picture. We have seen limited scalability could be there in using these technological barriers. Means recycling contamination could be there. That is the innovation. Social and behavioral issues could arise, as we have seen in other technology renewable sector also. So here also we can see in using circular economy, consumer may have certain limitations, so they should be made understandable. Awareness campaigns should be run. They may resist to change, so they need to be made more aware. Environmental concerns also arise. So we need to work towards each of the technology, but it is also having many of the challenges like community challenge, environmental challenge, technological challenge. So these barriers also come, but then we have worked towards its solutions also. So how we can use these circular practices by providing subsidies. So economic solution could be provided in this way. Market development could be there for that. Technological solutions could be provided to have more accuracy. So R&D could be used. Research and development, more technology should be developed. Social way also we can make consumers more aware by running more awareness campaigns so that we achieve these technologies. Circular economy could be enhanced. We have emission control also. So these are various challenges as I am highlighting. And to summarize, we can say that circular economy, waste management are one of the important technological developments, technological innovations that are contributing towards global sustainability. Although conflicts are there in terms of social, economic, technological barriers, but we are working towards having solutions in terms of R&D and government subsidies, etc. In the sector of sustainable transportation also, technology could be there. So sustainable transportation now being evolved. So it is having usage of like electric vehicles now running to have more transportation sector smoother, traffic congestions reduced. Electric vehicles usage is there, so it is now running by electricity instead of fossil fuel, so thus reducing greenhouse emissions. Greenhouse gas emissions are means contributing towards so many other means wastage, pollution, etc. Solid state batteries could be used, wireless charging roads could be there, vehicle to grid technology could be used, hydrogen fuel vehicles could be there. Key innovations towards that are green hydrogen production, hydrogen refueling stations expansion. So technological solutions could be provided for enhancing our sustainable transportation sector. High-speed rails could be there, autonomous electric buses could be used, e-bikes, e-scooters, smart bikes could be used, and they could be equipped with GPS. Conflicts again are there towards this sector also, challenges and limitations, conflicts in terms of infrastructure demand, because when we go for these sectors, we need to have charging stations. So it is going to involve more land usage and installation, infrastructure installation, energy demand could be there. But we need to work towards those R&D so that we can reduce that. Raw material constraint could be there, as electric vehicles may require certain other materials. So to obtain those rare materials could be a challenge. But then we could go for other strategies which can meet these challenges. So solutions to overcome those challenges, those conflicts could be renewable energy integration. We could invest in solar and wind energy together to power electric vehicles. We could go for recycling lithium-ion batteries so that we do not depend on new materials. So those lithium rare earth materials which we require, they could be recycled. Government policies could be there. Expansion of public transportation could be used so that we sustain our transportation sector. So to summarize, I can say it is contributing towards urban mobility, towards mitigating climate change, reducing carbon emission. So technological innovations like sustainable transportation could be used. Greener infrastructure could be there for sustainable development. So it is again playing a crucial role in climate change. We need to have this greener infrastructure using natural ecosystems to provide long-term sustainability. So innovation could be in terms of smart green roofs and walls. The technology used as sensor-based irrigation or AI-controlled water management or bioengineered plant materials could be there in terms of this example innovation for green infrastructure. Permeable pavement technology could be used, like porous asphalt, concrete, permeable pavers with underground reservoirs could be there. It is going to reduce storm water runoff, preventing urban flooding. So these are its benefits, we can say. Recharging of groundwater. Urban forests, smart tree canopies technology could be used, like drone assisted tree planting could be there. Now drone technology is being utilized for various disaster management, for other benefits like tree plantation, agriculture sector. We can go for drone assistance. IoT enabled sensors could be used for tree health monitoring, structural health monitoring, etc. So the impact is that it is improving our biodiversity. We can conserve biodiversity. The endangered species could be conserved. Conflicts again arise in this also, like high initial cost, space constraint in urban area, maintenance cost, resistance from stakeholders, climate adaptability change. So these are again conflicts as we have seen in other sectors, like I've explained earlier, our renewable sector, our circular economy sector, waste management sector. So similar conflicts arise here also. These are the challenges, limitations, which means make us not so much means progress towards these technology. But solutions again could be there, combining and integrating hybrid approach could be there with combining the strategies of IoT and AI for real-time monitoring, government incentives, community involvement, and circular economy approach, global collaboration, sharing of the best practices and technologies across the cities worldwide. We could collaborate and then we can promote this greener infrastructure. So to summarize, I would say it is one of the key players towards sustainable urban development. It is providing environmental, social, economic benefits, which were the three pillars to achieve sustainable development. While these challenges exist, technological innovations, strategic policy frameworks could be adopted, which will accelerate them. Cities worldwide must embrace green infrastructure as a long-term investment in sustainability. We should ensure more healthier, more resilient future for our future generations. Digital innovation for sustainability. So these are further benefits that how digital innovation for sustainability could be there. So using renewable energy, transportation optimization, waste reduction, environmental monitoring, conservation, resource efficiency, we can achieve sustainability. Transportation optimization, like we can go for ride-sharing apps to reduce emissions and usage of electric vehicle technology. Waste technology, we have waste management, we have already seen how IoT could be used. Digital innovations which are aiding towards sustainable development goals, like example here is for e-governance platform. If we go for e-governance, how it would benefit? Multiple benefits you can see here. Increased access to government services and information could be there by using e-governance. Improved transparency would be there. Citizen participation would be enhanced. Promotion of equal access for all would be there. So it would help in achieving our sustainable development goals, like goal 4 was quality education could be there by using e-governance. Reducing of the inequality could be there. We want equal access. We want peace. We want justice, strong institutions. So by using e-governance innovation, we could go for more sustainable development. Another program could be digital literacy training. We could have multiple benefits, like it could equip individuals with skills. For online learning platforms could be used by using digital literacy training. So on digital platforms, we can go for education purpose. It would help in participation of the digital economy, creating new employment opportunities. So with the help of this, we can go for achieving quality education, more decent work. Goal 8 was decent work and economic growth. So it will promote towards that. If we have this innovation, telemedicine, it can have these benefits that it could improve our access to healthcare services by using telemedicine approach. Remote means doctors would be remotely monitoring our patients, which may be placed in certain areas where transportation is not good, terrains are not good, and patients could not go to the hospitals in time. So telemonitoring could be used, telemedicine approach could be there. So it would enhance in the quality healthcare. So the sustainable development goal achievement would be in terms of good health and well-being, and also reducing inequalities. So it would provide equitable access to all. If we go for this innovation, precision agriculture, digital farming platform, we'll see that the crop yield would be enhanced, food waste would be reduced, farm management would be better. It would help in achieving zero hunger goal. We want for all, there should be no hunger. And responsible consumption and production goal could be achieved with the help of precision agriculture and digital farming platforms. If we go for environmental monitoring platform, carbon footprint tracking apps, it would have benefits like data-driven decision making could be there for climate change mitigation, adaptation. It would empower individuals and also businesses to reduce their environmental impact, because it would be data-driven if we go for digital technologies, and it would promote in sustainable land management practices. And the goals achieved would be in terms of climate action and life on land with the help of this innovation, environmental monitoring platform, and carbon footprint tracking apps. The innovation, smart grid and energy efficient appliances, if we go for, it would have benefits like increased integration of renewable energy sources, reduce reliance on fossil fuels, and lower energy consumption, and contributing towards climate change mitigation. So it would achieve affordable and clean energy by using smart grids, energy efficient approaches, climate action also goal would be achieved. The case studies being presented as I highlighted in my content slide. So first one is a tool against world hunger. How was this in Niger location in Africa continent? These were the challenges. Major issue was climate change was there, and it was reducing the crop yield. The food insecurity was there, and it was affecting the population. And if we go for digital innovation at this place, it has undergone this. United Nations Development Project has been there, and it was utilized at this place, and it achieved these. It could use, means they surveyed the farmers who were producing millets like crops. So those practices, best practices of those farmers was distributed among other farmers also, and better yields could be obtained. So it would help in achieving many of the goals as written here: SDG 2, SDG 12, SDG 3, and 15. So using this project, they achieved towards reducing the hunger, enhancing productivity, food and security, all those were achieved. Another case study presenting here is in Indonesia, that was tackling the uncertainty of nature. So many times nature plays its own role and we see flooding. So many of the people were displaced by flooding in Indonesia, and many of the lakes, natural lakes, man-made lakes, they were being mitigated because of this flooding, and it could not be managed properly. So again, the product means collaboration was there with the United Nations Development Project Agency, and the government of Indonesia, they partnered with that and generated collective mapping. They surveyed that area, they found which lakes were being flooded, and 200 lakes they could identify in that area and could maintain those lakes and prevent floods. So they were tackling the uncertainty of nature, and they helped in achieving our sustainable development goals of climate change, SDG 6, SDG 11. Case study 3, defending gender equality. So we are seeing that gender bias is also there. Women are not being paid. They are working 3 times more and still more being working in domestic areas and not getting that much income. So this initiative again was taken by UNDP. In Iran, this study was there, and they found that women are lacking the skills and not having equal opportunities. So they trained the women in other businesses like weaving carpets, cultivating figs, etc. And that helped in achieving our sustainable development goals like 5, 8, and 10. And it defended our gender equality. Case study for our own country, India, we have witnessed COVID-19 pandemic, how the population was being affected. We need to vaccinate each and every individual. So digital innovation was there. In 2021, vaccination was to be provided, and we could succeed in having our 1.1 billion people vaccinated with the help of this COVID app. So it's again a digital innovation that helped in aiding our sustainable development goal number 3 and 11. Towards future aspects, I would like to say that these technologies, as I have already highlighted, artificial intelligence, how it is contributing towards sustainable development. It can revolutionize resource management, predict and optimize resources. So it could contribute towards zero hunger goal. It could provide quality education in terms of imparting education and with the help of AI-driven tools. AI-powered chatbots could be used for providing alerts, and we can achieve this Sustainable Development Goal 16, peace, justice, and strong institution. And the technology was Internet of Things. So here in the summary, I would say that it could be utilized and each and every object which we see on the planet could be interconnected, and we could create smarter cities and have a more efficient waste management. That's a huge problem all cities are facing. It would aid in achievement of sustainable cities and communities. We could have a real-time environmental monitoring with the help of IoT, sensors, data collection, and climate action goal could be achieved with the help of smart grids, integration with IoT. We could go for optimizing energy usage. We could obtain affordable and cleaner energy goal. So how this AI, IoT have aided towards achievement of sustainable development goals that has been highlighted. Another technology is blockchain technology, that is to ensure that we have secure and transparent transaction. For security of transactions, financial transactions, we should use this blockchain technology. It would promote responsible sourcing practices. So responsible consumption and production could be achieved. Blockchain could also be used for secure data storage, for secure management in healthcare sector. So we can go for that good health and well-being goal achievement. So these are various technologies, digital technologies, emerging technologies, which are aiding towards sustainable development. We have seen that there is a digital divide. Still, the population is there in rural areas which may not be having all these facilities. So gap is existing to access of this technology. We need to provide this access to each and everyone on the planet. It can be used through various data plans, through digital literacy programs, training, affordable devices, low cost devices to be produced, which each and every individual can afford. We could focus on undeserved communities are still living in slum areas. So how we can reach to these innovations? So AI-powered healthcare systems could be used for in terms of local languages, in terms of local connects. We can go for reaching to undeserved communities. The future holds many more possibilities. So if we harness these digital innovations responsibly and inclusively, we can achieve a more sustainable and equitable future for all. So I would like to conclude my presentation with these few slides that, and also provide a summary that we have seen what a sustainable development means. It aims to balance the social and economic needs of the present and future human generations with the aim of preservation and prevention of undue damage to the health of the natural environment. The three pillars of sustainability were social equity, economic viability, and environmental protection. The major areas of concern still are there, like climate action, food security, sustainable economy, affordable housing, marine life, life on land. The target that was set for achievement by 2030 and the pace with which the world is going, on average, it has been found in the SDG report 2024 that only 17% of the targets are on track, and rest of the targets still having a decline rather in the progress. Instead of progressing, there is a negative progress, reversal of progress or limited progress is being visualized in many of the goals. Globally, a zero hunger goal was there, but with the pace with which we are going, it will be that still there will be suffering. By 2030 also, we'll see that globally 600 million people will still suffer from hunger. And in terms of greenhouse gas emissions, still we are accounting for almost from various sources like agriculture source, forestry, other land use. All those greenhouse emissions are taking place still, and they are amounting to so much of emissions. The food, agriculture, biodiversity, land use, and energy FABLE consortium was formed, and that also studied the current trend and related to the climate mitigation, biodiversity, water quality. As per the SDG report, we are seeing that nations are progressing, but very slow progress is seen. It is not accelerating the progress. So we need to work more towards achievement, towards sustainable development. In various sectors, we should go for imparting education, sustainable technologies education. To each and every community, we should go for imparting these training awareness programs. Digital space, we are seeing only increases there in the internet use, in the mobile use. The growth is there, progress is positive. The technologies like digital technologies, AI, IoT, blockchain, if we go for these technologies, combine these technologies, we could have more completion of sustainable development goals. Thank you.
Thank you, ma'am.
Okay.
Now the topic is open for discussion to the participants.
Yeah.
Participants,
Any comments from the audience? I hope I could succeed in explaining what a sustainable development means, how technological innovations could help in achieving sustainable development, what all technologies we could go for in terms of your engineering branches, and various academic institutions also working towards that. IIT Bombay is having a project to track the carbon footprint of the campus so that they can reduce wastage of resources and pollution. So each and every individual should work towards achievement of sustainable development. And your theme of this FDP was also for sustainable development. So I took this topic. I hope it has enhanced your learning and benefited the audience.
yes, ma'am. Yes, ma'am. No questions, ma'am. I think
Okay.
that's explanatory. So now I would like to express my sincere thanks to Dr. Brinda for her insightful talk on technological innovations for sustainable development. Ma'am, your presentation illuminated the vital role of technology in addressing global challenges and promoting sustainable practices. Actually, ma'am, your innovative ideas and examples inspire us to rethink our approach to development and environment stewardship. We appreciate your dedication and expertise in this critical vital field. Thank you, Dr. Gupta, for sharing your valuable knowledge and motivating us to embrace technological achievements for sustainable future.
Thank you, sir. Thank you.
Thank you, ma'am.
Okay, may I leave now? Okay, thank you.
Thank you. Now I am requesting to all the participants, we will shortly share the questionnaires by 6:30 positively. So please answer that questionnaire. Around 30 questions will be given, each question having 2 marks. So at 6:30, now you have 10 minutes, be prepared.